Good morning to everyone. This is Rohit from KonfHub Technologies, and I'm really glad to invite you all for Azure Kubernetes Day. So, today's conference is going to be themed around Kubernetes on Azure, and we have really exciting speakers lined up for today's conference. And we have various activities, like fun activities for all of you. So I would like to show you around the agenda, how it looks like, and what are the things do we have for today. So, all right. So I hope all of you are able to see my screen, and here how we go with the agenda and other details for today's conference. So as I mentioned, like this is Azure Kubernetes Day, and this conference is being sponsored by Microsoft Azure, and like there might be a lot of people who are not just attending this conference from India, so we are really like happy and very much excited for them as well, like those who are attending from other countries as well, because we have seen people registering for the conference from other countries like UK, from Brazil and UK. So thank you all for joining us today. And so guys, like there might be several questions you have in mind, so clearing them out. So all the sessions will be recorded, and the links and the recorded sessions and learning resources will be shared to all the registered participants via email and also updated on the website. And those who are looking for the speaker slides will also be updated on the website. After each and every session, there will be a Q&A slot where the speakers will try to answer two or three questions, picking them from the stream. So I request all of you to write down or comment your questions in the comment box so that our speakers can take them at the end of the session. Also, this discussion or the live chat is totally meant for technical questions and relevant questions regarding to the session. So we request all of you to refrain from any unnecessary messages. So here is the agenda for forenoon sessions. We'll start with a game time from that will start from 11:10 a.m. till 11:30, and soon after that we'll kickstart with our first session by Sayam Pathak from 11:30. Then we have Ronak Banka at 12 p.m. IST, and then we have Mahesh Kumar R from Microsoft at 12:30 p.m. After Mahesh Kumar, will be heading over for the lunch break. So the lunch break will be till 1:40 p.m. So we request all of you to come back after the lunch break because we have some more exciting things for all of you. So the afternoon session will start with a game time, which is quiz 2. And soon after that, we'll be starting with our first session for afternoon session with Nipendra Khare. Then we have Renu Saluja from 2:30 p.m. Then we have Mamta Jha from 3 p.m. Then we have Jayesh Sharma from 3:30 p.m. After Jayesh, we'll be having the last quiz 3 from 4 p.m. And after that, we'll be having the closing remarks and winners announcement for quiz. Also, there was another contest called a referral contest, which was part of this whole conference. So the referral contest is still open, and people who are participating and looking for the winners result, so we'll be announcing the winners soon, but not today, like mostly by 3rd of Feb, and the winners will be listed out on the same leaderboard website, because this will take some time for the organizing team to like validate the referrals and other things. So we request all of you to wait till 3rd of Feb so that we can update it on the website. So here's the code of conduct for today's event. So this event is dedicated to providing a friendly and welcoming experience to all attendees, regardless of gender, sexual orientation, disability, ethnicity, or religion. All participants are expected to display a positive community spirit by exercising consideration and respect to all that attend. Unacceptable behavior or harassment of event attendees in any form will not be tolerated. For the complete code of conduct, you can visit konfhub.com/code of conduct.html. So yeah, here is the most exciting part of the conference. So a lot of people will be inquiring about the quiz time, how is it, and what do we need to do. So in today's conference, we have three quiz time. The first one will be at 11:30 a.m. The second one will be just after the lunch break at 1:40 p.m. And the third one will be at the end of the conference at 4 p.m. So for each of these quiz, we have Azure Credits and Azure Certification exam vouchers for the top three winners for each of these quiz. Also, at the end of for the last quiz, which is quiz 3, we have cash rewards as well for our winners. So yeah, so I would request you all to attend each of these quiz. So for that, because for each of these quiz we have questions uh, from several learning materials, and most of these questions are framed along with our speaker sessions. So you have to attend the conference thoroughly and listen to today's session so that you can answer the questions well. So yeah, as I mentioned, there are several questions being taken from the learning resources. So here is the link to the learning resources page. So I would request you to go through this learning resources so that you can get more well versed with the topics, and you can participate in the quiz well. So now coming we have recently launched Azure Developer Community. So as the name suggests, it's a developer community, and it is spread across 100 plus cities in India. So you can go to the website is at dev.confhub.com, and you can find several communities listed based on the region, states, and cities. So you can go and find out the nearby communities so that you can join and attend all the regular events being taken by the expert speakers from industries and community contributors. So here's the link. Next, we have another similar event called Azure Dev Challenge. So, as the name suggests, it's a developer challenge, and this event is specifically meant for professional developers, but we are also welcoming student developers to come and participate. So, mentioning about what you need to do for this challenge, you will have to register first for the event, and then you'll be getting some learning materials which will be around. We have three different categories. One is Python on Azure, the next is Node.js on Azure, and then .NET on Azure. So you can pick up any of these learning materials or the learning collections, I would say. And once you complete them, you need to submit your learning profile to our website. So here is the website where you can find all the details. It's challenge.confhub.com. And also, guys, the submission ends on 31st of March. And at last, here is another event called Azure Developer Stories, and it's a event for developers who are very much keen in writing blogs or creating several contents. So developers who are looking for an opportunity to share their experiences with the community, you can visit this website, and you can find all the details regarding this event. And here is the link to the website where you can find all the details, and the submission ends on 3rd of April. To run any event and make it a successful one requires a lot of helping hands, and similar to this event, we have a lot of partners. Starting with our streaming partners, we have CloudRx, Computer Science Carrier, ShareLearn, and Tech Primer. So this event is not only been streamed to KonfHub YouTube channel, but also streamed to these four streaming channels. So we would like to thank to all our streaming partners and the participants, those who have joined from these streaming channels. So thanks to all. Then we have community partners who are helping us to spread the word about the event across their community. And we have 30 different communities partnered for this conference, starting from Bangalore CNCF, Bangalore Jug, Cloud and DevOps Group, Containers Meetup, CyberSci Squin, Developer Student Community, Docker Bangalore, Docker Delhi, Docker Pune, .NET Bangalore, dot question mark, Elasticsearch Explorers, Elastic User Group, Geek Community, Hypertrace Community, Java User Group, Hyderabad, JavaScript Meetup, Kubernetes and Cloud Native Online Meetup, Kubernetes and Cloud Native Computing Pune, Kubernetes Sri Lanka, Mozilla India, Mumbai Jug, Nashik Data Science and Cloud Community, Open Community, Pilot is Bangalore, Redis Labs, Serverless Meetup Group, Soda Foundation India, and Technology Cafe Bangalore. So we are really thankful to all our community partners for spreading our word across their community and helping us reach more audience for this conference. This whole conference is being sponsored by Microsoft Azure, so we are really thankful to them for sponsoring this event and sharing the learning resources that would benefit the community. So, guys, if you are loving these sessions and like enjoying the whole conference, so we would request you to make a tweet using hashtag Azure Kubernetes Day and tag us along with @KonfHub. This would really help us like in motivating and would love to see you tweet. So yeah, that's all from my side as of now. So with this, I would like to bring our first speaker for the conference. And before that, I would like to show like we have the quiz as well. So we'll be running the quiz for 10 minutes, and soon after that, we'll be running like we'll be starting with our sessions. All right. So here comes the most interesting part. So, guys, here is the link to the quiz. The quiz starts now and it will be ended by sharp 11:30 a.m. So, as I mentioned, like the top three winners will receive Azure Credits and Azure Certification Exam vouchers, and the winners will be contacted through email. And here are some rules regarding the quiz. Like there will be 10 multiple choice questions for each of this quiz, and the leading scorers will be shown on the leaderboard. So, this is the link. So, guys, there are so many people who have started playing the quiz, and there are like more than 700 participants. No, like it's more than 800. So, yeah, those who have not participated yet for the quiz, the link is there on the comment box. People who are facing issue with playing the quiz, there could be scenarios like you have not registered for the event. So play to play this quiz, you need to register first for the event, and with that registered email address only you can play the quiz. The quiz is open till 11:30. So request you to participate in the quiz as soon as possible, and this whole the event, the count of points and the time consumed is based on how much time do you take and how many correct questions you have come across based on that. So request you to take as less time you can so that you can be on top of the leaderboard. So right now we have Sakti on first position, then Dhanaraj, then Siddesha. All right, so we have more than 1,000 people participating in the quiz. Guys, if you are not able to find the link, it's there on the comment box. The link is conf.me/akd quiz 1. So, guys, we have 5 minutes more for the quiz. The top leaderboard is same. Sakti on first position, Dhanaraj on second, and Siddesha on third. So we have already more than 1,100 people. Also, guys, the top winners will be getting Azure Credits and Azure Certification Exam Voucher. The winners will be contacted via email after the event. All right, so we have a new top scorer. It's Sweta, and she has answered all the 10 questions correctly. So now the top scorers are Shweta on top, then Sakti, and then Dhanaraj. We have 2 minutes more for the quiz. So request the participants, those who have not yet participated in the quiz, please do that soon. We have more than 1200 people participated in the quiz as of now. All right, so we have another new top scorer. We have Gaddam as second position. Last 2 minutes left for the quiz. Soon after the quiz, we'll be starting with our first session by Sayam Pathak. All right, so we are about to end quiz. All right, guys, so we are just about to end the quiz. Here are the top scorers, and we have a new scorer on third position. All right, so it's 11:30, and this is the final score for quiz one. We'll take a note of it, and we'll be reaching to the winners. All right. So that's all. Thank you all for participating in quiz one, and we'll have another round of quiz just after the lunch break. So without like taking much of your time, I'll introduce our first speaker, Sayam Pathak from Sivo. Hi Sayam.
Hey, hi.
Hi, how are you?
Yeah, I'm good.
Sam, we are really excited and pumped up, Sayam, for your session. And just before your session, we had a quiz one.
Yeah, I saw the
So
excitement. Glad to be
yeah,
here.
we have like more than 1,300 people live for the conference right now.
Wow.
So yeah, so Sayam, would you like to give a quick introduction about yourself, like what you are doing and what your session is going to be about today? And soon after that, we'll be starting with the session.
Yeah, actually, I have a slide for that. If you can do the permit the screen share. So
Sure. Are you sharing your slide? Yes.
yes, I'm sharing the screen.
All right. It's live. Yeah.
Awesome. So hello everyone, and welcome to Azure Kubernetes Day. And I'm so glad to be here. And it's awesome that 1400 people are live on a Saturday morning Indian time and watching. Actually, people are watching throughout the globe, so it's really exciting, and I'm looking forward to this. So I'm Sayyam Pathak, working as Director of Technical Evangelism at CIVO, and this is my Twitter handler. Sayam Pathak, so you can follow me. I tweet a lot about tech, the new tech, and I'm a CNCF ambassador, Docker community leader, Influx Ace. I run a YouTube channel, so youtube.com/c/Sayam911, where I go live with other community leaders, discuss about tech, go deep dive into the sessions, and also go live with the co-founders to see from where grounds up the organizations have started and reached to success. These are some of the streams, and there are more. And recently, I wrote a book as well. It's not even a week, so it's 4 days back. I wrote a book on Let's Learn CKS scenarios. So it's basically for Kubernetes CKS certification. And this is the link, gum.co/CKS book. Or you can just find, CKS, Kubernetes, Siam, Gumroad, something on Google and make the search. And the coupon is first 100, 50% discount. I think only 20 to 25 coupons are left for this. So make sure you purchase if you are preparing for CKS. There are questions, detailed solutions, and there are 2 packs that you can buy. So if you are into Kubernetes CKS certification, you can have that. So today we are here to talk about Azure Arc, and very interesting topic. It's I mean I was really fascinated when it was launched at Ignite 2019, where Azure went a step ahead with the hybrid cloud and the multi-cloud approach. So Azure Arc is Microsoft Azure offering, which allows you to connect actually servers, Kubernetes clusters, and even run the data services on anywhere on any infrastructure. So, but for this particular demo or this particular talk, we'll be focusing on connecting Kubernetes clusters. And let me give you a brief overview first. What happens is in our day-to-day world, so we have developers who develop the applications. Now there are various frameworks to develop the applications. Now in the containerized world, developers are developing the applications which are containerized based. They are running the application on across various infrastructures. So right now there is a lot of offerings available to run your application. You can run the application on servers, on bare metals, on Kubernetes clusters, which can run on maybe your home lab or on a data center, or maybe any public cloud, which can be any. So there are a lot of public clouds now that are offering the Kubernetes service. So you can run multiple what you call cluster, multiple applications in multiple Kubernetes clusters across various infrastructure across the globe. So this is happening. This is actually happening now. Now is the time where people are not tied to a single infrastructure. People are not tied to a single vendor. People are using the best of the breeds of all the clouds and trying to manage it from maybe a single control plane, or they want a solution which connects them all. So for this, Azure launched Azure Arc. It is still beta, so it's not it's not a fully matured service, but it has grown over time a lot in the past 1 year, and it helps you connect. So let's see here. So this is suppose Azure Arc, and you have your maybe a Kubernetes cluster running in the data center or other public clouds, and in CIVO. So CIVO offers a K3s managed K3s Kubernetes cluster that you can provision under 2 minutes. So like I was saying, you can use the best of all the clouds. And so if you want to run the workloads very quickly and you want to use the best of CIVO, you create a CIVO cluster and you can run your workload over here. Now the point is, you are an existing Azure customer, and you still want, and you also have your data center where you are running some of the workloads, and you have chosen CO to run another set of workloads, but you have Azure account and you want to manage, mostly you are using Azure services, you are very comfortable with the Azure Resource Manager, Azure policies, all the monitoring logging solutions that are available, and you want to expand that to other infrastructure, other of your infrastructure where your application is running. So Azure Arc provides you to control any Kubernetes cluster from a single place. So you will be having Azure portal and you will be having Azure Arc. You will be able to connect any Kubernetes cluster to Azure. And so in the demo also, we'll see that. So we'll be connecting CO K3s cluster to Azure, and you will be able to manage that and perform all the operation policies, etc. on Azure. So this is on a very high level what Azure Arc offers. Now, why it's exciting? It's exciting because you get the power of an existing a very mature cloud provider to manage Kubernetes clusters across infrastructure, and you get the ability to choose the best out of all the infrastructures where you want to run the app. So you're not tied to a vendor, and there are a lot of features. Now let's talk about the features what Azure Arc provides. It's not only like you just connect the clusters and you can see them, okay, and it's fine. So but what exactly it offers? So let's see what it offers. So first is GitOps and Flux. I really like this. Now GitOps is on a very layman or very simple terms, I would say, just there's a Git repository. You have some YAML files over there, and your application, I mean, you are able to pull the code and deploy to your Kubernetes cluster. So this is the GitOps model, and any change in the GitHub repository, your new version of the application or the changes get deployed to the Kubernetes cluster automatically. So there is no there should no manual intervention should be there. So if there's a change in the master branch or the main branch, and you have pushed the code, so it should automatically be deployed to Kubernetes cluster. Now, Azure Arc can help you implement GitOps using the open source technology Flux to implement GitOps and deploy applications to the clusters which are not AKS or not created on Azure infrastructure. So you can use a CO K3s cluster. You can create that, connect it to Azure Arc, then enable GitOps. You are done. Now this particular application from the GitHub repository where it is there, it will be deployed to this particular cluster using Azure Arc. I mean, this is how effective it is. Now this is only one feature. Now let's go to other one. Running data services anywhere. This is also very niche feature. So you can run MySQL, Postgres, managed databases, and you can use the power of Azure Data Studio, and they will run. I mean, there are certain specific steps and the requirements that comes on the page when you try to run data services on the servers which are not present in Azure infrastructure. So you will have to maybe create a namespace or run some agents first so that it gets connect to Azure services, and then able to create Postgres proper definition. The CRD, basically the controllers will be going on. So there's a concept of operators, custom resource definition in Kubernetes. So that will be there. So you create a custom resource of Postgres or MySQL, whatever database you want to use, deploy that onto the Kubernetes cluster. It will be able to connect. Then you will be able to use Azure Data Studio, and you will be able to use that to manage your Azure managed database services on the Kubernetes cluster, which is not on Azure. You understanding, right? I mean, so many things are happening in this place. So Kubernetes cluster is not running in Azure, but still you are able to use Azure, some of the Azure services and features to manage them and get more insights out of your infrastructure. Let's see another one. This is also very great feature, governance using Azure policy. So a lot of time happens where you have servers. Okay, this one, yeah, where you have servers. You have your K8s cluster, K3s clusters, and all these things. By the way, in Azure, you can connect servers, legacy systems running on bare metals, Windows, because Azure, it's Windows, so it has very good compatibility over there. A lot of Linux, almost all the Linux distributions you can manage using the Arc. Now, let's say you have you have onboarded 10 Linux servers. Now, what happens is you can create something which is called Azure policies. Now there are tons of Azure policies, which I'll show you in the demo. So Azure policies helps you to manage or audit or govern what all infrastructure you are onboarding to Azure Arc. For example, SSH access is disabled. So this particular, say that this is Azure policy, and you have applied it across all the servers. Now, as soon as you get a new server and this is not compliant, so in the portal, in the Azure Arc, you will be able to see a compliance issue. So you will get to know what are the compliances that you want to follow and where and all it is failing. Sorry, where and all it is failing. So governance using Azure policies, infrastructure compliance is a really good feature that Azure provides. Azure Arc provides. Now this is both the diagrams are taken from the Azure documentation, and this is Azure Arc, and you have this Visual Studio and all that. So you are able to connect securely to run the Postgres MySQL on your multi-cloud infrastructure. You are able to connect the Azure Stack and the edge devices. You are able to connect any hardware and the on-premise solution to Azure. So Azure are again another thing. So you have Azure Resource Manager, Azure Portal, Azure Policy, CLI, and much more that you can access. Basically, the monitoring solutions as well, the logging solution as well. So you can manage them, and it will help you to. So this is you are the customer, you have the tools, and you get a single plane, cloud native practices, security compliance, RBAC, all the resources are there in Azure you can use for your infrastructure that you connect with Azure Arc. So that's how it is on a very high. I mean, summarizing this, Azure Arc auditing Azure Arc resources, auditing using Azure Arc, then GitOps, Azure Monitor integration, tagging and querying. So you can tag all the resources and then you can query on the basis of the query manager over there. Single management view. Yes, you get a single management view. Connect any servers, connect any Kubernetes cluster, run data services anywhere. So you are getting the point, right? So many things, so many benefits from Azure. You are able to get I mean, you are able to connect all the infrastructure and you are able to use the best features out of your hardware, your data center, or any other public cloud vendor, and you can still use Azure Arc services if you want to use all these features and have a single control plane, control view, management view of all your infrastructure, whether it's servers, whether it's Kubernetes cluster, and also it gives you to run the data services on your infrastructure. So this is the Kubernetes day, Azure Kubernetes day. So the demo we'll be doing is connecting the Kubernetes cluster to Azure Arc, and what it will do is it will install some of the agents. So obviously, when you think of connecting an infrastructure that is a piece of infrastructure that is running on your hardware or your data center or any other public cloud, but it is separate from Azure. Now what happens is, in order to connect it to Azure, so this is your infrastructure and this is Azure. So in order to connect this piece of infrastructure to Azure, there has to be some agents that has to be deployed. Similarly, it will deploy these set of deployments in Azure Arc namespace. So like the config agent will be there that monitors the connected cluster for updates, compliance state, source control. Then the controller manager is there, orchestrate interaction between Azure Arc components. Then the metrics agent is there to have the to collect the metrics and optimize the performance and other things. Then cluster metadata operator gather cluster metadata, including the version, node count, and all these things, so that it can show you on the control plane. And resource sync data syncs the cluster metadata to Azure. If you are scaling up, scaling down, adding nodes, changing the labels, all those things has to be synced back as well. Then you have cluster identity operator, maintains the certificate for managed identities for Azure resources. And flux log agents collect logs from the flux operators that deploy as part of source control configurations. So this is what will be getting deployed. I just wanted to tell you about all these so that you have a fair bit of understanding, like what all is getting deployed to the cluster, and what is the need for each of the component in the with respect to Azure Arc. And now let's move on to demo. So we have demo time, and we'll be connecting CO K3s cluster to Azure. Now I'll keep this setup aside, and I'm gonna have to type now. Cool. So let's go here. So what we have right now, this is by the way, this is a fairly new thing that we'll be launching to the customers probably next week. So I'm basically, this is the first preview as well. So we have a new region in New York right now, and these are the Kubernetes clusters that I have created already. Let it refresh. So I have two clusters out of this. I think the one CO Azure, I haven't actually applied any configurations, but we can check that. Let's see. Okay, so we don't have any Azure Arc namespace. That is fine. What we'll do is, so one cluster is already running, and let's create another one also because I want to show you two things. Okay, I have 13, 14 minutes. So I want to show you by the CLI method as well and by the UI as well, so that you have the understanding of both. So let's create another one. CO Azure E. It's maybe a medium. I don't know whether I have quota. I should be having it. See. Okay, it's creating, so that's fine. So let it create, and let's move on to Azure Arc. So now what we have is this is the portal.azure.com. I am in the Azure Arc service, and these are some of the overview features. Add your existing infrastructure, deploy Azure data services anywhere, view all of your Azure Arc resources. Now this particular service is actually this particular service. So you can see I already have connected some of my infrastructures from already to Azure Arc, and it has the type, the location, and the resource group, and all that stuff. So let's add a thing. Now let's add an infrastructure. So we want to add the infrastructure. Now it asks what you want to add. You want to add servers, you want to add Kubernetes cluster and SQL. So these both are in preview. So they are not the generally, I mean, not the general, not the stable one, I would say. So because the preview means there will be changes and which will be for the good based on the feedback of the users. And this one is out of preview. This one you can use for the servers, but we'll be using today this Kubernetes clusters preview. So let's click add. Okay. Now, some of the base things that you have to do. You need to have Azure CLI. You need to connect your connect to the cluster. Your Azure CLI basically should be connected to Azure portal. You need to have some of the CLI extensions like connected K8s and K8s configurations. You need to have Helm 3, and you need to have kubeconfig file to connect to the cluster. Very simple things. So I think we already have things. So these are the kubeconfig files. So we'll be using CO3 one. I think I'm using, yeah. So CO3 one do not have anything applied. So we'll be using CO3. And let's go back. Oops. Yeah. Kubeconfig file. So we have all these things. So let's go to next. We select the resource group. So I already have a resource group created. You can see the resource group as, I mean, you can create your own resource group. It's fine. Now is the Azure Arc cluster details. You have to give a cluster name. So let's say we gave awesome event, just like that. So we give this name, we select the region, and outbound proxy, you can is the cluster behind the proxy, so you can give that proxy details as well. It's publicly accessible, so I don't have to give. Next comes the tag. You can give different tags. I already have created a tag called cloud, and I'll give it as CO, and then it asks you to run the script. So this is already done. We already have the account set. Now what we'll do is we'll run this command. But I cannot run this as it is because I have to run it against kubeconfig file this. So if you go down, there is a small check that is given. You can use --kubeconfig flag to provide the kubeconfig file. So we give CO3. Now what is happening? What is happening is it is using the connected k8s. Obviously, it is in preview. It may change or removed, whatever that is. But right now, as of now, this is the command to connect your existing Kubernetes cluster to the Azure Arc. So if you come here, soon you will be seeing a new namespace getting created in the cluster, which is CO3. And here, it will create a new namespace. So this takes about a minute or so, and in a minute it will be ready, because it has all the resources I told you will be deployed in this particular namespace itself. So it should apply these set of resources. So all these resources will be deployed in the Azure Arc namespace. And also we have our another cluster running. So meanwhile, we download the config file for that. So you can see it creates under less than 2 minutes. So CO maybe 1, 2, 3, let's do 4. Okay, so we have this. Now what we do is, yeah, so Azure Arc namespace has been created 27 seconds ago, and we can see kubectl get pods -n Azure Arc, and then the kubeconfig just to see the resources. All these containers are container creating, the thing that I told you. Let me just zoom in a bit so that it's visible to you all. So you can see kubectl get pods, and it is container creating, and it is again container creating few of them. Now all of the pods are running. So we have successfully connected, and here now, after all the pods are running, it will take another few seconds, I think, to give output that the cluster is in connected state. In the meanwhile, we can also check now the other cluster. So what we'll do is have this gist, and so whatever we did with the CLI, sorry, whatever we did with the UI, I'll also do with the CLI. Just, yeah, so you can see the cluster is registered, so it's finished, and this is the certificates and all that thing that gets generated as a JSON. So it tells me that everything is perfectly fine. I can go here, I can go next verification, and I can just close it. I can go to Azure Arc and just do a refresh. Where it is? Okay, I'll do a refresh from here. So you can see awesome awesome event cluster is there. Now these are the things that I was telling about. You can apply. So we have 6-7 minutes still there. So let me just now accelerate my speed a bit. So these are the policies. So policies, I told you, is for the governance. And we can see that there is one policy which is already applied. So this one policy that I created already, which is SSH access from the internet should be blocked. Since it is COK3S, we don't provide SSH access, so it is blocked, so it is 100% compliant. And what you can do is, if you want any additional policies that you want to apply, you can go to the policies, you can assign policy, and you can assign basically all the select all the clusters, and you can save them, and you can then create the policy definition. And you can see there are 499 policies already available that you can choose from to apply across all your infrastructure, that will help you to give you the governance, the auditing on your infrastructure, whether it is compliant to whatever the security needs that your organization needs. So I think that's a really cool feature, and it should be used. So that's how it gets used. Next awesome feature is GitOps. So let's explore this. So in this particular awesome event cluster, what we'll do is we'll add a configuration. This is the GitOps configuration. Internally beneath, see, the operator type getting used is called Flux. They might change in future, but I think Flux does a decent job. So configuration name, we can just give the same, and the namespace, let's give demo. Repository URL is github.com/im1814/Azure Arc. Just let me check that. So yeah, it's Azure Arc, and it's a simple voting application by Azure, and so it creates all the namespace, the deployment, and everything. It should create, and whatever we can choose, namespace level, cluster level, any parameters. So git, okay, I did spelling wrong, so it's good that I checked immediately. GitHub.com, so I'm on Azure Arc. Awesome, looks good to me. Hope it works. So I have added the configuration over here. Now what we'll do is, if I do a refresh, we can see the configuration has come over here. What will happen in some time is it should create a namespace. Yeah, it's CO3. Now that, yeah, we should see the namespace. So it should create a new namespace in a minute when it gets synced. Basically, it will apply the Flux. It will apply the Flux agent, which will be able to establish the Flux connection, and then it will try to pull the code, apply it to the cluster, create all the resources that are there. That is the namespace and all that stuff. So that will be happening in the backend. Meanwhile, since this is happening, what we'll do is let's run the CLI commands and see how it works. So we'll go here, we'll do Azure connected case list or white. So this will show the connected clusters, which looks good for now. And let's now connect the cluster using the CLI. So just we did for CO3. So let's connect the CO4 one. And the name should be demo CO. I hope I haven't used demo CO name. Yeah, I haven't used the demo CO name, so that should be fine. And there it is. And then when it is when this particular thing is connected, we can just so you can see, let's go back. So I'm switching back and forth, but you should be having a fair understanding. So this is the CO3 cluster, and you can see 45 seconds ago, demo namespace got created. Why it got created? Because demo namespace is there. We have the demo namespace. In the demo namespace, all the resources will be applied. How I can say that? Because you can see operator namespace is demo. So all the pods will be deployed in the demo namespace. And in some time, this should the pending should change to install. So we can just see kubectl get pause in the namespace demo. You can see that the pods are running already, so which is good. And soon this should be changed to installed. I don't. I think it might be installed. Yeah, so it's installed. So it might take some time to sync the state of the cluster with the Azure Arc. That runs in the every operator cycle. That it checks the status every few seconds, and now it's getting refreshed. So this is how you can implement GitOps. So we have implemented GitOps. We have implemented policies. We have connected the cluster using UI, and we have connected the cluster using the CLI. It is still getting connected. We have 2 minutes. I think it will be connected in 2 minutes, so which is fine. But all in all, what happens is you can connect the servers, you can connect the Kubernetes cluster, you can run create the SQL Server Azure Arc cluster in in the server details, and then you can run the script. So it will tell you all these things that you have to run for a particular server where you have to run this, so that you can run your SQL server on the infrastructure of your choice. So which I think again cool. Another thing, all these resources you can manage from single plane. Another great thing is the pricing. Yes, you can check the pricing. For now, I think the control plane is free. Yes. So Azure Arc extends single control plane to bring services is offered at no additional cost. So this particular thing is not causing additional cost. But if you use any additional services from Azure, like the policy, monitor, and all that, they will incur a cost. So basically, you can you can monitor as well some of the clusters. So you can enable the monitoring. So this is the inside preview, and it will redirect you to the documentation of how to enable the monitoring for the cluster, and you can use the Azure monitor to monitor the resources. So I think, yeah, so this cluster is also connected, and the final step, and we are done. I just need a minute or two. So this is the final step to connect. I hope I have given all the names correct. If not, then it's fine. I have already shown you. Awesome. So the GitOps is also done. Now, if I go to Azure portal and I go to the Kubernetes clusters, I should see demo CO. And in demo CO, if I go to GitOps policy, I should see a new policy. So this all happened. This is same, but we created via the UI, but this one we created via the CLI. So that's pretty much it about Azure Arc. I think play around with it, connect your infrastructure with Azure Arc. It's no harm. It runs agent. You can delete the namespace later, and then probably just play around it. Enable the monitoring. Use some of the Azure services. You can also query some of the things. I know everything I cannot show in one particular demo, but if you see open query, you can query based on tags, based on things, other things. So all these things are available as part of Azure Arc. Enable the monitoring, show how you are using the monitors, and any questions, you let me know. I can try to the best of my knowledge to answer them. And we can see
That
CO4.
was a really nice session, Sayam, and like we can see there are a lot of engagements going on in the comment section. So like since we have very less time left, so I would pick one question for you that you can answer, and for the rest of the questions you can like go offline and answer them.
Sure.
All right. So here is one question from Namit. If you are able to see screen, it's here.
Okay, how to rebuild the cluster if you want to change the kubectl parameters. So the thing is the agents that are running. So what were the agents? The resource sync agent should be responsible to sync the cluster metadata to Azure. So it's a pods. So if you change any cluster configuration, so anyway how the pods will pick up the state. So whatever the Azure resource sync agent is deployed onto your Kubernetes cluster, it will sync the latest state of the cluster and the latest configuration that you have done given on the cluster to Azure Arc.
Right. I hope that answers to the question, and Namit is satisfied. So Sayam, we'll be sharing the live URL with you so that you can go to the YouTube channel and answer to most of the questions which people have asked in the comment section.
Sure. And yeah, make sure you subscribe to my YouTube channel, Sayam911. And the book is out there, CKS certification. I don't know how much more the first 100 coupon is valid. So if after that, I wouldn't, I mean, this was for the first 100 users itself. So make sure if you are preparing for CKS, that might be a good asset for you. And thank you, Rohit. Thank you to the KonfHub team for having me here. It was really awesome speaking with all of you. And, I really liked the way the whole thing is projected and the agenda, the games, everything I like a lot. Thank you.
Thank you so much, Sayam, for joining us for the conference, and we look forward to have you in our future conferences as well. Thank you so much.
Awesome. Bye all. I'll be there in the live chat. Bye.
Sure. Thank you. So it was Sayam Pathim from Sivo. And next we have Ronak Banka from VMware. So Ronak will be joining for the session live from Singapore. So we'll be adding him to the screen. Hi Ronak.
Hey everyone, can you hear me?
Yes, yes, yes. How are you doing,
Okay,
Ronak?
I'm good. I'm good. How are you doing?
Yeah, we all are good. So
Great.
we have 1,000 plus live viewers right now for the conference.
Yeah, that's
So
amazing. Yeah. First of all, thank you guys for organizing this, and thank you everyone who is actually attending the conference.
we are equally excited to have you, Ronak, for the session. So, Ronak, would you like to share a screen so that I can put it on screen and
Sure. Okay,
so that
just give me a
and
minute.
give a quick introduction about yourself and
Yeah.
tell us what this session is going to be about today.
Okay. Sure. So I'll just quickly share my screen. Just a sec.
Yes, it's there.
Can you see my screen now? The presentation one.
Yes, it's live.
Okay, great. Hello everyone. Thank you for joining the conference. And today I'll be speaking about event-driven scaling with KEDA and AKS because obviously we are talking on Azure today. So just a brief introduction about myself. My name is Ronak Banka, and I'm part of VMware Singapore. I work here as the senior solutions architect, and I've been working in whole cloud and containers for almost over 8 years now. And in part time, I love cooking. So I love cooking, trying out different cuisines. And if you want to follow me on Twitter, that's my Twitter handle. If you want to check out my blog, you can check out the blog as well. Okay. So when we are discussing about like AKS and all the event driven and other like fancy words, there are obviously a lot of knowledge out there, but today we'll just focus on this agenda. So we'll discuss why we need auto scaling, what are scaling options are there in Kubernetes. So while I was watching Sayam's video, I saw like few people commenting that there is no session for introductory Kubernetes, but I think maybe we can take a minute or two during this talk. So we'll discover what all scaling options are there in Kubernetes. Then we'll go to what is actually KEDA and how we can use it. Then we'll see that what is the KEDA architecture looks like. So what are main components of that whole system and how it works. And then finally, we'll go to the demo where I'll show how to actually deploy a function on AKS, and then we can scale using KEDA. And then at the end, question answers if people have any questions. So why auto scaling? So when we talk about containers, when we talk about all the cloud native technologies, one thing very common is the scale. So those platforms gives us a lot of flexibility to configure our systems in a way that they can actually auto scale by themselves. Someone doesn't have to go there in person and then like scale up your system. So for example, if some organization is having like $1 billion sale or some other super sale, they don't want people to just sit there and scale things manually while a lot of people are actually trying to access your marketplace or whatever product you're offering. Uh, so then we require the auto scaling. So auto scaling helps us to scale up and scale down our system based on few like metrics or based on a few different events, which today we'll explore. So why we need auto scaling? So if you look at this slide, uh, this is actually like a house burning. You can consider it more of a, like, you can say, not exactly an organization, but more of an event, something like sale or something like that. People say, okay, we don't need auto scaling, but then when you have like thousands and like lakhs of user accessing your marketplace, things started crashing. So you will see a lot of your systems are crashing because you were not actually prepared for that kind of load on your systems. You were not prepared of that kind of traffic. And that's where the whole point of auto scaling comes in. It helps us to basically configure our system in a way so that we can be prepared for unexpected scenarios. So don't like treat auto scaling like you don't need it. You surely need it. It's just that you will need little bit practice to be more confident on these things. Now, what all scaling options we have in Kubernetes? So I'll just give like a very maybe a minute overview of what is Kubernetes. So for those who are not familiar with what is Kubernetes, it's basically a container orchestration platform which gives you like all the building blocks on top of it, on around it, to create a mature platform, to create a mature system for your organization, which can scale in itself, which can actually integrate with a lot of your enterprise systems, or more you can say like some of the legacy systems. When we talk about scaling in Kubernetes, there are different ways where we can actually scale our systems. So before we had all these event driven and like fancy scaling options. There were like very limited options in Kubernetes. So these were like very few options. I mean, these are few options which are available now. Obviously, we have the manual scaling, which was there from the very starting. We have something known as horizontal pod autoscaler, which helps to autoscale your Kubernetes pods based on few metrics, but those metrics are limited out of the box. Then third is something known as virtual nodes. Virtual nodes, we'll discuss what it is in like maybe a brief overview, but then virtual node helps us to like scale your infrastructure, not exactly infrastructure, but basically your application scales. And then last, we have the event-driven scaling, which today we'll discuss about. Okay. So let's move to the first one, which is actually the manual scaling. When you deploy an application on top of Kubernetes, this is like the easiest way, or like this is the very, you can say, a noob way of doing scaling, even though it's not very effective because it depends on human action to scale the application. I mean, for sure, you can basically plug in the GitOps and all, but then again, someone has to change those numbers. Someone has to change that configuration so that Kubernetes can actually scale up your application. And when we talk about manual scaling, it's basically done using simple kubectl command. So you can just give kubectl scale, your deployment name, and tell how many replicas you want to run. So for example, if you are running one replica, you want to change it to two. So you can just run the simple command, which is there on the screen. Similar options can be done for scaling your cluster as well, but that's using like Azure CLI, AZ CLI. You can scale your clusters using the CLI, but again, it's a manual step. The second one is the horizontal pod autoscaler. This is more advanced from manual because this type of scaling depends on some system metrics to scale your application. If you are running your application and you want to auto scale your application in case your CPU percentage goes by 80%, you can actually configure that using HPA. You can say that kubectl auto scale, your deployment name. You can say how many maximum number of pods I want. I don't want to go beyond this number because maybe you don't have enough capacity, or maybe because you have like tested your application to like manage or to handle that much traffic. And then you basically give your the CPU percentage, which defines that, okay, if my CPU percentage is more than 80%, then just auto scale my deployment. One of the limitation of HPA is out of the box, they're like you can just like scale by CPU percent. So they are like limited metrics on which you can use HPA. So we look into how the event-driven scaling is helping us along with HPA to create a more dynamic system. The third one is the virtual nodes. So this is, again, the virtual node, it implements something known as virtual kubelet in AKS cluster. Virtual kubelet is an open source project, but then there are like a lot of different providers who are supporting it. For Azure, it's Azure Container Instances. So for example, when you're running your application platform, you're running a Kubernetes cluster, and you have integrated with ACI. When you have actually when you have more traffic and you don't have enough infrastructure on your cluster itself, virtual nodes helps you to scale your application on something known as, again, it's called by the name virtual nodes, which is not part of your infrastructure. It's basically it's provisioned by like Azure itself in your own network. So it looks something like this. You have your AKS cluster, and then you have your ACI instances. You can say Azure Container Instances. When you have a lot of traffic on your main cluster, what it does is that it actually bursts your application. It moves your application to the ACI. So it runs the pod on those ACI instead of running on your cluster. So this is again like a different implementation of how you can use ACI. And the final one, which is the event-driven scaling. So this type of scaling can actually use a lot of different metrics from different sources. So we'll be focusing on this one today. Like in the backend itself, the event-driven scaling, or in our case, KEDA here, it uses the horizontal pod autoscaler itself, but then we'll see how it actually utilizes the HPA in backend. And then, sure, it can be used in combination with virtual node. So if you have if you have to scale your application on your Kubernetes cluster, you can integrate event-driven and virtual node. So under certain circumstances, it will basically burst your application on ACI. Okay. Okay. So main topic for today, what is KEDA? So KEDA stands for Kubernetes-based event-driven autoscaler. Yeah, it was easy to create a short form for that. So what does event-driven autoscaler actually does for us? So how does KEDA works is it works alongside your standard Kubernetes component, for example, HPA, and it extends the functionality without overwriting or duplication. So in for KEDA, when you deploy this architecture, when you deploy this component in your Kubernetes cluster, it basically exposes additional metric API, which can be used with HPA. So for example, when you deploy KEDA, it's an operator, it's a Kubernetes operator. So it has two major roles. One is the agent, and the second one is the metrics. So what is the role of the agent? Agent helps the cluster to actually activate and deactivate your Kubernetes deployments to scale to and from zero, or like how many pods you want. So it again, if you see, it's not actually doing outside something. It's basically like extending the functionality in your cluster itself. And the second role is the metrics. So KEDA acts as a Kubernetes metrics server, which exposes like event-driven data, which exposes the event data from different sources, and that can be actually used by HPA. So you are still you still have the horizontal pod autoscaler. It's just that the backend API which it is using, it can use from KEDA. So it exposes that because it has more richer format, or it can integrate with more sources for your metrics. Okay. So this is a very this diagram is from the KEDA website itself, but this is like a very overview of the architecture for KEDA. So obviously we won't go in deep, but we'll just look at the very basic components which are actually responsible for all the work inside your cluster. So obviously we know that on top we have the Kubernetes API server, and then the big blue box is actually the KEDA. So it has three components. One is metrics adapter, the second one is controller, and the last one is scaler. Scaler is responsible for communicating with your external sources. So we'll see what all sources it can integrate with. Scaler is responsible to present the metrics from external sources to HPA. Then the second component we have is the metrics adapter, which in itself is actually it's an API which integrates with HPA. So you have your scaler, then you have your metrics adapter. Now someone needs to take care of the whole loop situation, or in Kubernetes term like reconcile loop, which is managed by controller. Controller is responsible for managing all the objects which are created for KEDA itself. So they are like different CRDs which are exposed by KEDA, and when we create them, our controller is responsible to take care of those CRDs or the objects. The most important thing over here is the scaled object, which is like on top left. So scaled object, it actually defines the mapping. So you have an external source. Now you have your application. So scaled object defines your mapping between your actual deployment and between the trigger source. So we look into the example, what does the scaled object looks like. Yeah. Okay. So KEDA scalars. this is one of the best thing which I like about KDA is basically the number of scalars it can integrate with. So it can integrate with your queues, it can integrate with your analytics tool, it can integrate with your Kafka, MongoDB, MySQL, Prometheus, Redis. So there are a lot of connectors which you can use with KDA. So today we'll actually look into how we can use the Azure queue, so Azure Storage Queue in our example. Okay, most exciting thing, demo time. So before we actually go on to demo, let's do something which is pray to the demo gods, because demos are like the most scariest thing which can which can go wrong, like in any presentation, no matter like how many presentations you have given or how many like demos you have given, there is always like 99% chance for your demo to fail. So yeah, let's just pray to demo gods. So today I'll be deploying a Node.js application, a JavaScript application, which in backend uses, it's basically not an application, you can say it's more of a function. So it's a node function which in the backend integrates with Azure Storage Queue. And what will happen is that when we put a message into that queue, our function will, like our Kubernetes and along with KDA, will be responsible to spin up our instance, which we'll look into the demo. Okay, so just give me a sec. Let me share my screen again. Oops. Okay. Okay. Akshay, can you see my screen? The terminal. Okay.
Yes.
Yeah.
Okay, great. Okay, so over here, let's do one thing. So what I've done is I have already created a Azure Kubernetes cluster, because obviously it takes some time. So I don't want to waste that time during the demo. So I've already created the cluster here. So I've already created a cluster on AKS. You can, Microsoft obviously gives a very good documentation on how you can get started with the creating cluster itself. Over here, I have just used a different way, which I'm trying now. I use,
Sorry to interrupt. Like, will it be possible for you to increase the size?
okay, sure. Just give me a second. Is that better?
Yeah, that's better.
Okay, great. So yeah, so over here, I've already created the cluster. Now what we'll be doing is, my cluster is already deployed. I've already created the kube config here, which is sitting in my folder itself. So I won't be doing cat on that, but I can just show that, okay, what does the cluster info looks like. So our cluster is running on Azure AKS. If I do duplicate nodes, I can see that, okay, I have my two like workers already deployed over there. Okay, now before we, so when we have to deploy an application on AKS, obviously you can use kubectl to deploy. So in our case, the first step is we'll be deploying the KDA itself. So KDA is a Kubernetes operator. So what I've done is I've already created a script so that I don't have to do everything at the same time. So we use Helm to deploy KDA onto our Kubernetes cluster. So as of now, if we see that so for now, we don't have, oops. So we don't have the KDA namespace. So what we'll be doing is we'll be deploying our KDA over here. So it will basically add the repo. It will create the namespace. It will use the Helm chart to deploy the KDA operator in our cluster. Uh, Now, obviously, we won't be going in how operator works and all, but again, it's just basically like simple Helm chart, which deploys two components. One is the operator, and the second one is, one is the controller itself, and the second one is the metric server. So once this is deployed, we can see we have two pods running inside our cluster. So just give it a minute. Yeah, so now it says it has deployed. Oops. So let's see what we have in our, so if you see our namespace was created. Now if I want to do, I want to get pods in KDA namespace. So we have two pods here. One is the operator, like the controller, and the second one is the metrics API server. Metrics API server is, like I said, it's responsible to communicate with your HPA. Now, what we'll do is we'll see that, okay, we don't have any uh, deployments here. Oops. So we don't have any deployments in our default namespace. So today what we'll do is we'll use, so the good thing about like Azure, so there is a Azure CLI which is provided by the organization, which is known as Funk. Funk is basically CLI to do all sort of things which are related to the functions. For example, you can create your functions using this particular CLI. You can actually even deploy your functions on Kubernetes using the CLI, which we'll do today. So what we'll do is we'll first create a new application for us, which I'll say the name is KDA function app. Yeah.
Ronak, sorry, will it be possible for you to share the entire screen, because right now it's partly like half.
Because okay, I'm kind of concerned because my screen is 34-inch wide, so I'm not sure how it will look like on the StreamYard. I can try doing that. Just give
Right
me a
now,
minute.
the whole screen being shown on StreamYard.
Okay, just give me a sec. Let me stop and share again.
Yeah, sure.
Oops. How about now?
Yeah,
Okay,
it's now you can maybe zoom it.
okay, sure.
Yeah, this is
Okay. Yeah, okay, great. So yeah, so what we'll do is we'll create a function here in this repository where I already have the kubeconfig. And I'll use the func CLI to actually create my function here. So once I give this, it will ask me that what kind of worker runtime I need. So I'll be deploying a Node app, so a Node function. So I'll use Node, and then I'll use JavaScript in this case. So good thing about the CLI is it actually creates like Docker file and everything for you. So if we go to this one, KDA function app, let's see. So we have four files here. One is the Docker file itself, which again, it's very basic Docker file from boilerplate, which creates your application repository and everything here. So now we have our function folder. Now what we'll do is I'll add a function here. So I'll just say func new, and it will ask me what kind of function I want to create. So I'll use like a template from Azure itself, which is using Azure storage trigger. So I'll use number 10 and I'll just name it Q trigger. So once I have this Q trigger, let's check what is the content of the Q trigger. So it creates a few files here. If you see, it creates your index file, which is nothing very simple. It's just processing your queue. And then you have your function.json, which defines that what you want to actually, like how you want to bind your queue over here. Yeah. So what we'll do is over here, I've already created a storage queue, but yeah, it's not obviously something very fancy. It's just like few. I'll just show you how I did that. So it's just like very simple commands of AZCLI. So it helps you to create a storage queue. Once you create the storage queue, it you can actually get the connection string, which is required for connecting your function to your queue. So what I'll do is I'll just get my connection string. Yeah, I have to like I wrote scripts for everything because I'm very lazy at writing the code. So what we'll do is we'll just copy this string and then we'll go to our app. So in our app, we'll define that string inside our storage. So once we define this in our storage, we'll need this metadata. So we don't have to worry about like creating everything by hand. For example, secrets and all those things. Those are actually taken care by the func CLI itself. So in here, all I have to do is I just have to define that what my connection key is, which I define in the local one. And
Ronak,
yeah,
it's again not visible.
is it too small?
Yeah, it's too small, and the thing is like the text are not contrasting to your background of terminal. Like
Okay, how is it now?
uh, it's comparatively better, but like there are people like commenting in the chat box that
Uh,
is it possible
okay,
for you to like change the background color of your terminal to black?
okay, just it's already black actually on my side.
But here it looks like bluish something.
Okay, strange. Just give me a sec. Let me check. Okay, let me just edit the session. How is it now?
Yeah, I think better. And if you could like zoom it.
Okay, sure. Okay, let me see. Is it better now?
I think like guys, participants who are like watching this session, like is it like visible for you properly? Text color to white, is it possible? Like there are people asking.
Okay, sure. Okay. Okay. I can use. Why? It's actually white. Strange. It's white on my side. Let me check foreground.
Okay, okay. Okay, so like
Is it
it's
better?
yeah, yeah, it's better than before. Yeah, yeah, yeah.
Okay. Great. Thanks. Uh, Sorry, everyone. Uh, yeah. So I'll just quickly show. So yeah, we have configured our queue trigger. We have created like our connection string in the local setting file. Not what we'll do is we can actually deploy the app using the func CLI itself, and then so what I'll do is I'll just name it maybe hello AKS day. Yeah. So when I gave hyphen registry, it helps me to create the Docker image itself. So I don't have to do it. I just have to do a Docker login here. But for example, if you're trying to use a private registry, then you have to do some additional steps. So once I give this command, what it will do is, okay, I have given dry run. That's why it actually gave me the whole thing. So what we'll do is we'll actually do app.yml so I can make some changes. Okay. Oops. additional values here so that, okay. So let's do one thing. Let's open this. So what you see at the bottom is actually the scaled object, which is responsible for scaling your application. So I'm configuring that, okay, my minimum replica count is 0, maximum is 5, and then what is the trigger? So whenever I will have an event in my queue, it will actually process that. Okay, can you tell how much time is left? Okay, so let me do one
Actually, we
thing.
are already like 6 minutes
Yeah,
behind.
okay. I started late, I guess. Okay, no problem. Just give me a minute. I'll just show one thing. So, so what I'll do is I'll just quickly apply this. So this will actually deploy it will create a deployment, it will create a scaled object. So if I do here, get deploy, I can see that the deployment is already created, but there is no pod because there is basically zero requirement for now. So what I'll do is I'll put this on get pods. Oops, oops. Yep. So, and what I'll do is I'll just use my other browser to load some values in the queue. So I've created a script. So what I'm doing is I'm just like putting some values in the queue. And once we have those values in the queue, we'll see that in our pods will start creating because now we have some of our values in the queue. So see, uh, now when we have once our values are available in the queue, the trigger will, okay, image will back off. Why? Okay, let me check something. Okay, I'm not sure if I had Docker login. Sorry, just give me a sec. Oops, yeah, that's why I said demo gods thing. Okay, let's deploy again. So yeah, it is building my image. Yeah, I think that was the issue because I didn't log in, so that way it was not building the image, and then yeah, it started creating the container. But again, there was no image over there. So probably just take a minute. It will just deploy the app. Just a second. Just give it a minute. So once the image is, so the good thing about the CLI is that you don't have to do all the manual steps of creating your images and like deploying separately. You can just use the CLI, which will do the end-to-end things for you. So, okay, let's just check. I'll just again apply this one because, no, okay, no problem. I'll just show that one. Come on, demo gods. These things already exist. So my queue is already getting filled with the values. I'll just show what kubectl pods. Okay, yeah. So we'll see what, yeah, see. So basically now our application is running, which is processing, and there are a few instances which are terminating because we don't need them. So we can set the triggers and all. Now see, because we have trigger, we have more values in the queue. So it actually scaled to more number of pods. And because my maximum is 5 limit, it won't actually go beyond that. Okay. So yeah, I think, yeah. Oh, no, it actually created. Yeah. Okay. I didn't had my limit. Yeah. My limit was on the other one. So by default, there is no limit. I mean, it's actually 100. But yeah, I have to configure 5, so no problem. Okay. Just give me a sec. So yeah, I think that was all. Thank you, everyone. If you have any questions, please feel free to ask.
So, Ronak, it would be great if you could share the command lines so that we
Okay.
could share.
Yeah.
Yes.
I'll try to write the blog over the weekend, and I'll share with you.
Sure. We are
I
also
don't I
planning.
don't have it handy now, so yeah.
No problem, because we are planning to send a like post-event mailer to all our registered
Sure.
participants. So have that blog also on that.
Okay. Great.
So thank you so much, Ronak, for joining us today. And since we are running a bit short of time, so
Hmm.
we'll be able to take the questions live. So what we'll do is we'll
Sure.
be sharing the live session URL with you so that you can go
Hmm.
offline to the questions we're running.
Okay. Great. Okay.
Thank you so
Thank
much,
you.
Ronak.
Thank
Really.
you for having me. Okay. Thank you, guys.
Thank So that was Ronak Banka from VMware. Next, we have Mahesh Kumar from Microsoft. So let me quickly have him on the screen. Hello, Mahesh.
Hey, thank you guys. Um, able to hear me?
Yes. How are you doing?
Doing good.
All right. Right. So, yeah, Mahesh, we have started this whole conference at 11 a.m. and right now we have more than 800 and 900 people watching.
Hmm. Sure.
And before you, we had Sayam Pathak and Ronak as well. So right now it's your session, and so before going to that, I would request you to give a quick introduction about yourself, what you're doing, and what this session is going to be about today.
Sure. I think you can share my screen. I will start from there because I don't want to hold people from lunch. So lunchtime, guys, don't go. You can grab
No
and
problem.
watch it. Otherwise,
You can stick to your that whole session slot. We can still extend the session.
sure. Which screen you guys are able to see now? Uh,
Yeah, we are able to see you can present your whole screen.
okay. Let me share the second screen, screen two, so that I can run my PPT. Good now? Is it good?
Yes. Yeah. All right.
All right. Thank you, guys. Thanks, KonfHub, for arranging this. And I know that it's a Saturday, but I still see 800 plus people are watching. It's good to see that you are spending time on learning something new, enhancing your skill, instead of doing something else. I appreciate your thought on that. And myself, Mahesh, and I work as a cloud solution architect with Microsoft. And I'm with Microsoft for 7 years and close to 17 years in the industry. And I'm certified application developer in Kubernetes and Linux, so and so. And without any further ado, and I'll start the session with the introduction about topic, what you're going to say. It's about what are the must-know topics or maybe the best practices in AKS to achieve the better resiliency, right? Uh, so the session takeaway would be on three areas, like what are the best practices you should be aware of when you are working with clusters in a productions, and also what are the day two challenges you'll be seeing in scenarios like production. Day one challenges are easy because you deploy a plain vanilla microservices into the production, but day two challenges are slightly complicated, because when you more and more workload if you try to move, and also when the customer started using the deployed Kubernetes cluster, you will get into the day two challenges. That's what I mentioned as a day two. And you should be aware of what are the upcoming features, SLAs, node pools, availability zones, and all of the thing. And with that, let me go to the Kubernetes maturity model. This is not something from Microsoft or anybody here. It is actually a general opinion from the company that you say these Kubernetes maturity models into 7 phases. As a beginner of Kubernetes, you will be into 1 to 4, right? Either in a prepare, transform, or deploy or confidence. But The topic today, what we are discussing, is specifically applies from phase 5, 6, and 7, right? It means that how to improve your operations, how to measure and control, how to optimize, or how to get maximum return of investment from your existing cluster, right? So the phase 1, 2 need not have any introduction. If you look at it, it is all about how you can prepare or evangelize about Kubernetes inside your organization to get convinced about going for a Kubernetes. And then third phase is deploying a hello world or maybe a simple application from your company deploying to the Kubernetes. And fourth phase, you see the CTO, CXOs agreeing that more and more customers are open to or move to Kubernetes workload. And then you will see problems like sometimes you see the timeout from the DNS, maybe the cluster is not responding. All these things challenges would come in because the Kubernetes cluster itself so massive. There are so many moving components within this Kubernetes, so it is so difficult if you're not able to take care of this. But I encourage this take this Kubernetes maturity model. There is a URL in the bottom right. It comes from CNCF, and there's a third party who has blogged about it. I love this analogy of moving from phase 1 to phase 7. But in this topic, we're going to see specifically about phase 5 onwards. So I have a very strict timeline to cover here, and let's see. Let's run through one by one. Quick check if everything is going good. Can somebody put a
Yes, everything is
message
fine.
in the? Okay, cool. So the first thing is multi-tenancy. I mean, in general, so best practices, there is no limit for best practices, right? If you are doing something with EKS, GKE, AKS, I mean, these best practices goes on and on. You can actually author a book about it. But in 30 minutes, I thought, like, let me understand what the customers are facing through and what is relevant for the customers today, and then summarize it here neatly so that you will get maximum out of it. The first one is the multi-tenancy. As you see that namespace is a logical isolation boundary, you not have an introduction. There are always recommend to have a multiple namespaces, one for a prod, a UAT production, and also even for the customer also, you can try to have multiple namespaces so that without jumping into the other namespace or kind of a violation. So if you are still not convinced with the namespace level hierarchies or isolation, then consider about the private cluster in AKS. Private cluster would give you the complete capsule of holding the end-to-end within the single cluster kind of thing. So you are not actually running multiple customers into the same cluster. And then scheduling, despite we see the lot of documentation prescription about you should use the quotas in a better way, and also pod distributions properties, or maybe the node affinities, chains and tolerations and node selectors. But it's disappointing to see that customers are still just start with the hello world and then start replacing the hello world application with their images what they are trying to bring in. They'll continue to go to the production, but they never come back and then adjust all these requirements. So I would say consider the advanced features or maybe schedulers like uh, anti affinity and also pod affinity in a greater way. The reason is that if you are running a Redis cache pod within the application front end, and you always want to have a pod affinity, but you do not want to have a something else with the front end, right? So all these things can be controlled with anti-affinity. And networking, of course, you can use the network policies. Netpol is the better place, and also you can control the in and out of the traffic. Authorization, RBAC, AAD stuff, which need not have any introduction. If you are a beginner, then I'm sure that you will be uh, using the custom authentication and then slowly get into the AAD kind of stuff. Last one is about container policy. I think we'll see all this thing in a coming slide. Uh, Enforce the resource quota. This is a very must thing when you are running an application in production. You must have this quota set. Otherwise, we have seen customers saying that there is a timeout issues frequently. It's sporadic issues when there is not able to reproduce the issue. And it's a lot of to and fro, but we always recommend to have this resource quota, whether it's a small development or maybe a small UAT or a customer demo. This has to come as a practice. So try to have this resource quota always set so that you will not get into the problem of limiting going to the part loop, kind of a crashing and other thing. And the second one is the part distribution budgets. And of course, we should have this part distribution budget when you have a 40 plus nodes cluster or maybe 15 nodes cluster. When there is a frequent updates or a cluster upgrade, when you do, you should always have the maximum available and minimum available and maximum unavailable. There are 3 or 4 parameters around that in PDBs. So play very smartly there and then make sure that minimum maximum available parts can serve the existing customers. So I don't worry, all these things will be shared as a slide, and this all these are documented in the Microsoft AKs also. But I'm trying to give everything in a crisp of 30 minutes and see. The fourth one is about the node affinity, and node affinity, as discussed, you want to specifically pin certain workload in a certain nodes, then node affinity comes in play. Let's say you have the Kubeflow kind of a workload and maybe the N series requirements or GPU requirements where you need to push those containers to a specific nodes, then you have to use this node affinity. Then it will actually make sure that those workloads are properly pinned to that particular nodes. And yeah, this is one of the best practices we see customers are not rigorously following it. Fifth one, I think Cube Advisor. I'll show you the Cube Advisor sometime towards the end if you have time. It actually, this is a nice tool. Actually, you can run this tool and then it will tell you what is missing in your cluster, right? We had seen a customer having 45 plus nodes, and he was also surprised to see some of those mistakes. It goes to the production and then it was living there for almost 6 months. But when you run this Cube Advisor kind of a tool, it will tell you what you are missing in your production cluster. And yeah, we regularly run this latest version of open source and detect issues. Yeah, of course, I mean, the Cube Advisor, they keep enhancing it. So once in a while, maybe twice a month, you try to run this and then see if there is any gap. This is how the sample Cube Advisor output looks like. And it will tell you it's actually, by the way, it's a console application and it's available in GitHub. And I ran it for one of my cluster which I prepared for this demo. So you can see that there is a resource limits missing, memory limits missing. It goes on and on. It also tells you how to remediate or maybe take action on closing this gap. It actually points to the Kubernetes document is where you can refer it and then set those limits. And sixth one, we see the uptime SLA. I think there was some question in the chat window. I'll take all those questions towards the end. Otherwise, you can connect with me in the Twitter or email ID. Uptime SLA, and as you know that the Kubernetes or AKS, we don't provide SLA for the master nodes, right? We provide the SLA only for the agent nodes or worker nodes. So, but in case of your customers or financial customers where they want to have end-to-end SLA, then don't shy away taking this uptime SLA, which is actually worth taking it because it just comes around $70, but it still guarantees that you have a better SLA than going without SLA if you have a very stringent SLA from your end customer. I'm surprised to see that many customers are not aware of this because it's been lately introduced in AKS. So if you go to the Azure pricing calculator, you will see that uptime SLA as a separate checkbox. Per cluster it comes with certain amount. So just enable that so that you will get it covered for SLA point of view. And if you are deploying the AKS cluster across the availability zone, it is 99.95. And it's better than 99.9. Reason is it is 44 minutes versus 22 minutes or 20 minutes, right? So I would always go for this deploying across availability zones. When you are creating a cluster and say deploy, it will ask you whether you want to deploy across the availability zones or you want to strictly put into the same region. So leverage the availability zones to avoid or maybe insulate failures if there is any zone level failures, right? By the way, the master nodes are the master node, which is the control plane, is already having the deployed in a fault tolerant way. So you may not worry about or anything about this master nodes. So all you have to take care of your worker nodes or agent nodes. I think this is what we discussed. And then how to create availability zones from the command shell, just say dash zones 1 to 3. And if you want to deploy it across the 2 zones, and You can also specify zone 1 and 2. And this is how it's been split between zones. So some of the customers actually who has already started this long time back, they're stuck in single region, let's say in central India. Unfortunately, last year we had some failure due to the power issues in the central India, and they are all stuck in the same region. They could not able to move anything out. So all this thing can be avoided by mitigate the risk by splitting into multiple zones. You can see that in the screenshot. I ran it by Southeast Asia, a single node pool, which has been three machines has been split into three different zones, right? 1, 2, and 3. And I see there is a question about if time permits, can you also speak about multiple schedulers and the daemon sets best practices? I would encourage to check the document. If there is no detail about that, please reach out to me, but I'm sure that there will be a detailed description about that. Let's proceed. Then another one, 8th point is that we always recommend to have more than one node pool, right? There are some customers who started as an early bird with the Kubernetes. They all stuck with the single node pool, or maybe before this virtual machine scale set, there was no node pool concept. They were all deploying as it is with 30 nodes, 40 nodes. But after seeing this node pool benefits, they are trying to convert everything into the VM scale set based cluster. The advantage of the node pool based cluster is that you can actually segment or bucket into multiple customer size. Let's say the customer premier customers, right? For the premier customers, you can say high-end virtual machines with high memory in a different node pool, because each of those VMs within the node pool should be an identical type, right? In another node pool, you can actually have a lesser VM size or maybe type with a different GPU combination and all other thing. So that by having a different node pools, you guarantee that if anything goes in one node pool, also you can try to avoid everything goes down kind of scenarios, right? You can define as much as maybe 5 node pools, 6 node pools, and within namespace isolation, again within node pool isolation, you'll have a better granular controller to switch if there is anything goes wrong. Have one more node pool taking the customer workload. There is a question about is AKS support Azure scale set. Of course, the AKS now VM scale set is what we call. It is now underneath the AKS. The VM scale set has been used to manage this node pool. How about the DR scenarios in AKS? I think there is a detailed documentation about the DR and how you can actually back up your cluster. Vijay, please check that documentation. And I think that's all about this node pool. In the screenshot, there is a couple of node pool. There is an agent node pool that comes by default. All the core Kubernetes concepts, or maybe the some of those agents and other things, core components will lie on that agent pool. But the my node pool is what the worker node pool. You can actually bring down to 0 also this my node pool. I will talk about the starting and stopping also sometime later now. And Azure policy, this is one thing which is not taken very seriously or considered very lightly. But trust me, there are companies, kind of publishers, kind of companies where I work with, where they're completely mandate the Azure policy as they must think to proceed, right? This brings a very strict compliance or maybe the stringent best practices in deploying any workload on the Kubernetes, right? And there is a no limit for this policy. I can also author a custom policies using the ORM templates. A sample policy is that when you are deploying a cluster, when you are deploying the containers to the AKS cluster, we are mandating that or telling that it must have the resource quota limit set, or maybe the key vault, or maybe the having the multiple, maybe the, two replicas kind of, all this kind of a policies can be enforced. And so that the governance would kick in from the day one onwards, so that without by mistake also, by mistake also, your DevOps guy or new guy who is in the team will not get into any trouble. So already there are 10 plus policies already authored for you, mostly used policy kind of thing. But the last one is like, custom policy is something which I feel that, you can write it in your ORM template kind of a style and then apply that so that, it works brilliantly and take care of all those compliance demands. Autoscaler, I think at least in the AKS, I see the HPA and autoscaler has been documented and been used. I haven't seen the VPA inside AKS. I don't know. I'm not sure whether VPA has not been considered or it's still yet to come. But I see the good samples and explanation about, you have to use the HPA and cluster autoscaler approach simultaneously. It's not very kind of a rocket science. Just go and enable this autoscaler as in the command line or in the portal also. You can just go and just tick mark so that automatically tell you what is the minimum node and maximum node you want to have it, and then what are the parameters to look for autoscaling. These are like overlooked properties or small things which I surprised to see missed in the productions workload, which I wanted to share it here. And then seventh point, which I want to say, this is a brilliant feature I see recently discovered. It's still in preview. Earlier, I used to go and manually stop all those VMs, right? But now in the console, just look at the sixth line and seventh line. Just in one line, if everything is set from 1 to 5, that's a one-time activity. I could just go and trigger a stop command. It will actually go and shut down the complete VMs so that all the state will be preserved at least for 12 months, right? This is a brilliant, not only for a development, this helps for the companies who want to show the demos to the end customer. At the end of the demo, they want to shut everything and keep it as it is, and then resume it when you want to showcase the same demo to the end another customer, right? Earlier, I had a lot of issues going through individual VMs, stopping individual VMs, but all those things can be taken care by just shutting the complete cluster by stop command and then start command. And by the way, this supports only with the VM scale set because these command actually go and affect the VM scale set more port. So try to consider this as well. Even in case if you are using for a development purpose, maybe one node, two node cluster, at the end of the weekend, during the weekend, you want to shut it off. You can also automate this with the logic apps. There is no end for it as long as there's a console CLI is available here. There is a question comes from, okay, even stopped cluster charged. No, the stopped cluster will not be charged. Only the charge for the master nodes will be considered. So there is a question from Sunil. Is start stop available for private cluster? Of course, yeah. 12th one, there's a capacity planning, which I surprised to see when I work with multiple customers who are preparing for RFPs, request for proposals, or maybe they are quoting tenders. They do not know how to how to size the node, right? All they have is their SaaS application or maybe the VM kind of a VM deployed application. When we ask, how many customers are going to use this application, they might say 20,000 people are expected, or if it is a public service companies like if the central government projects, we do not know how many people are going to use that use this application when it goes live, right? Because it's kind of a B2C kind of thing. When it's open to the public, it is so difficult. But at least we should know that how many parts can go into the node and how big is your part, what is the memory requirement for this part. So there is a link in the bottom. Actually, it will tell you how to size your AKS cluster, right? How many nodes you want, and how many subnet you have to have it within the nodes. And the reason all this thing, these small things will affect you in the long run, right? If you're not looking at, if you're not sizing it properly, we had a kind of, the subnet exhaustion. We had it in one place where they have to completely redeploy a new cluster, right? You have to plan it all the things, in ahead of time so that you will avoid last minute surprises when you move the production workload. Okay, and 13th point is about use diagnostics. And I wanted to show this beautiful thing, which they already incorporated in the portal. If you are using AKS today, just go to the AKS cluster, and then the left side you would see diagnose and solve problems. It's kind of a robot kind of thing where you go and click next. It will tell you, it will pull certain things and look at the certain signals and say if everything is green or if something is red, it will tell you upfront. Let's say if you are running, if there is any out of memory exceptions, there is a pod actually going in a crash loop, you want to quickly do a quick check on that, just go and say, just run this and then see, what is the result out of that. If everything is green, nothing to worry. So in fact, the networking is what I like it. It's very complicated in Kubernetes world, and it tells you that just run it, and then if there is any issues, kind of subnet exhaustions, or maybe there is issue in the DNS, health of your core DNS, all these things can be automated way of, just run the scripts and then let you know in the Azure portal itself. There is a question. Is it possible to create a private DNS zone using Terraform? I haven't created, but Terraform is the first class citizen now supporting the Kubernetes. In fact, across the Azure, AKS. Um, Going forward, you will find Azure ARM and also Terraform side by side supporting multiple workloads. Please share the capacity planning, Joe. Definitely, I'll share the complete slide because it has got some of those hyperlinks embedded. Fourth one, Azure Advisor. Azure Advisor will not be charged for you, so but still it actually goes and look across all your workloads. It could be a Kubernetes service or app services, virtual machines. What I'm interested is Kubernetes services. It is showing that some of the things are missed. Let's say there are 2 Kubernetes services running here. Azure Advisor is telling that the PDBs are missing, and also there is unsupported Kubernetes version is detected. And this all helps you when you have more than 10-15 clusters, with each cluster is having 60-70 nodes. And trust me, I've seen these customers getting benefited out of this by running this in Azure Advisor. If you have a small cluster, then doesn't it's not a problem. But when it goes beyond certain limits, then you need some tools to every day the DevOps comes and look at these kind of tools to get an idea what's happening, what actually happening in the cluster and health of the cluster to proceed next. And the next tool called Azure Periscope. And Azure Periscope is a free open source tool. And assume that you have a 40+ node cluster deployed in Chennai region, and there are some sudden issues. The cluster is not responding due to some underlying issue in your application, which is taking 100% CPU or 100% disk, and which is actually completely hampered your application to go down. And when you raise the ticket with support, the support team will ask you to retain the cluster to collect the logs, right? But unfortunately, you cannot retain this 40-node cluster for a long time till you do this investigation or troubleshooting. So Azure Periscope is a fantastic tool. Just run this tool, point into Azure Blob Storage. It collects the required logs and then dump it to the centralized place so that you can actually release the cluster or delete the cluster, make a room for the next cluster creation, right? So if you are trying to incorporate a proper DevOps, maybe SRE kind of a practice, I would recommend as like Azure Advisor. Azure Periscope is also another tool. Many people are not aware of it. So all it does is simply collect all the logs and then put it to the Azure Blob Storage. So when you file a ticket with support, you can tell that, hey, this is the blob storage account, or maybe the SAS key. Please go and download the logs for your investigation. So this will help you to just proceed, move on with the new cluster creation if there is something goes wrong completely. And then 16th point is something like a production checklist. Maybe these are some of the things I keep learning even now. Thanks to some of my colleagues in Microsoft, I spoke to Yusuf and Sumit Kute, Saurav Bhartav. All these people are like Kubernetes experts in Microsoft India region, and we see these are like collective knowledge we keep sharing internally, and all these 16 points I've collected so far, all based on the customer experience documentation plus field experience. The 16th point is something which I see something is not documented in documentation. If you look at the regions, right? If you deploy to a particular region, let's say in central India, you cannot move to a different region, right? I've seen customers moving a production workload for cheaper region, and then suddenly due to compliance or ISO audit, they want to move completely to a different region to get it to compliant, 100% compliant, right? So these are small things which you have to keep in mind, right? Regions are very pinned to a specific thing. You cannot move Kubernetes cluster as it is to a different region as like any other resources. And then version, definitely you can move to a different version, upgrade. And then sixth point, I think of third and fourth point, as you know, we already discussed about Azure zones and availability, other thing. Services, the fourth point is something like, we have seen multiple places the ingress controller Nginx has been used, but I see the traffic as also used for, the traffic is one more open source. I see but these are small things we have to thoroughly do a POC and see what is the limitation with the ingress, or what is the limitation or support by going with the open source tools, tools like a traffic, so that avoid the last minute surprise. And then fifth one, and select the appropriate VM type. Right, this is very important thing. So once you select the region and select the VM type, you are stuck with that. There's no way you can actually do a vertical auto scaling or change the VM SKUs or anything like that. Only option is to create a separate node pool with a different VM size. It's all actually adds your lot of operation timing and a lot of ifs and buts and surprises. So select the proper VM type before you dive into the production, and then get go from there. I think sixth point we talked about in length, like sizing and enforcing the quota limits and everything. And the seventh point, in general, we recommend Azure CNI. You can actually see that the documentation has Azure CNI versus Kubernetes. By default, you will see Kubernetes has been deployed, but if you see some limitations, then you can go with Azure CNI. And I put in something specifically in bracket. A Kubernetes, go for a Kubernetes unless your organization has a restriction on IP address to be assigned to the subnet. Otherwise, Azure CNI is the first class, and I would say go with Azure CNI, and you will be support-wise, troubleshooting-wise, everything is covered end-to-end, right? And eighth one is something, a new feature I see. Security is also a hot topic these days, and you want to restrict the kubectl command access to your, or maybe the API server access by whitelisting certain IP ranges, right? Let's say you and your colleague is going to quite often going to manipulate these API servers through command cell. So you can whitelist your IP and plus your colleague's IP, and then from there, so no one can actually kind of access those IP outside of those whitelisted thing. When you say API server access, it's just your kubectl access, right? And then storage and databases. I think storage itself is a big topic. Actually, we had a multiple Excel sheet within Microsoft. We see what to use, what not to use, the stateful set. Inside the stateful, again, multiple things. So I want to just keep it simple. Always go with the third party, whoever the cloud provider is there, and go with their first native solution or cloud native solution, so that you will be support wise covered end to end, right? If you are fairly matured, if you are matured well enough, then you can do a lot of experiments with a lot of open sources. But otherwise, go with the default managed services or a PaaS services as much as possible from the support wise, and also the easy networking and bringing the data in and out quickly. And the ninth one, monitoring. And that is an interesting story in monitoring aspects. I can take a couple of minutes here because I want to stress the importance of monitoring. But by the way, the over monitoring also cost you a lot. I have seen a customer paying 10 lakhs, 12 lakhs just for somebody enabled all the checkboxes in the Azure diagnostics, and then end up like paying 12 lakhs. And don't overlog or over monitor, and because it's all cost at the end of the day. And also, I see there is a session from Mamta today about Prometheus as the tool. You can use Azure Monitor or FileBeat or Prometheus also as a tool to monitor. I'll take a minute to explain the importance of monitor. This happens to one of our customers in AKS, December or November timeframe, November end, we had this issue. The complaint was, they called me and we called all our solution architects, and they said there is a customer of them complaining that there is a timeout when they try to log into the application, right? And it seems like a application timeout issue for customer, but fault is on AKS, right? They are pointing AKS as the unreliable or not able to find out the problem with the AKS. It's actually, by the way, it's a sporadic issue. There is no way to replicate this issue consistently. So we had a multiple calls with the customer, end customer. Once in a while, the end customer was facing that, when they try to log in that www.contoso.com/login, they face that frequent login failure, or maybe the application timeout or page cancelled, action cancelled, all these things. And then first day of troubleshooting, we come to know that it was actually core DNS was failing. And then everybody started blaming that, hey, there is a core DNS issue. Core DNS is not reliable. AKS is actually having some problem with the core DNS, and all this thing going around. Second day, when we progressed and when we moved on, by enabling certain monitors, we saw that the underlying disk which they used for the nodes was P10 disk. P10 is the capacity disk, which is actually 500 IOPS per second, and that is the default disk you will get it. And then so what has happened once in a while, and they see that the throttling has gone beyond the 500 IOPS. It has reached sometimes 1000 IOPS. Due to this IOPS choking or a starvation, we are facing cube DNS issue, but core DNS issue. Um, so you will find very erratic behavior, right? You will find that login page cancelled, or sometimes you will see the report was taking time to prepare or slow down. I mean, it could be anything because your underlying disk is starving with IOPS. So all these things can be monitored only through better monitoring, in pipeline, how is functioned as a cluster. That's what I keep saying, that when you have 40 plus or 50 plus nodes, it is so difficult to keep an eye on all these parameters. So we should have a very concise monitoring in a better way to avoid such IO starvations or network starvation, so that you can better recover quickly. 10th one, there's a node restarts. In fact, the node restart is also it's been getting automated slowly. I see there is a checkbox coming that in AKS when you say automatically upgrade when there is a new version. So it's a kind of autopilot. I'm giving complete control to AKS that if there is any OS patching has been done. So what will happen now? It will add another couple of nodes, or maybe minimum one node, but it will depends on the cluster size. It will add the reserve node, so that it will restart the nodes after patching, so that it's complete automation kind of thing. So the reason I'm stressing this 10th point, I had seen customer not rebooting even after 6 months, 7 months, right? So that is all surprising. So these rebootings also have to be there, which we cannot, Kubernetes, AKS cannot enforce to reboot it, right? So, but right now it is actually getting kind of a preview mode where just check it. We are giving the autopilot control to AKS to take care of this rebooting also. And otherwise, you have to use this cured KURED for automating the node reboots. That is what I have, and there are 16 points which I covered. It's, by the way, this applicable to any cloud today, right? Any EKS, GKE also, right? So you learn and then align your company goal or strategy towards the workload. And the reason I'm mentioning as a baseline cluster, I'll come to that. I'll show you the baseline cluster or maybe a sample cluster, how it should look like, right? And then start operating with that, and then best practices, revisit the best practices. There is no end for these best practices. Attend KubeCon kind of a conferences, and then you can borrow all these best practices from Kubernetes to the AKs also. And then iteratively, work on this, work as a team, and then keep sharing your knowledge with your teams also, so that you avoid last minute surprises. And these are some of the links which I see that if you have a Kubernetes AKS in production today, you should be aware of what has been released, what is there in the release notes, what is currently previewed. Don't use the preview features for your production, but it's good to start piloting, in your UAT, or maybe not UAT, maybe pre-staging or development mode. And we saw Ronak was talking about KEDA. KEDA was in preview for a long time, and it's been GA, and it's also accepted as a CNCF. So it's those kind of a project, you should not miss it, right? You should actually start piloting when the project has been kicked as open source from some of the brand names, and then see that whether it's really helping your problem, and then start accepting as a production thing. And there is a public roadmap. If you see anything is missing in Kubernetes today, in AKS today, you will see that definitely in the roadmap, whether it has been prioritized in the next release somewhere in the May or April timeframe. And then you can also request any of the features missing in the AKS. There is a link to raise the request, and there are some known issues, right? Of course, known issues are like documented. If there's a set of customers who are using Kubernetes also facing some issues, which is actively getting investigated. All this thing has been captured in the known issues. In case, let's say the CSI, we have something, container storage interfaces using the key vault and other thing. Those are new things coming up, and the CSI has been adopted recently, and it has gone GA some places. So if you are surprised by some issues, then always check in the known issues. And then public FAQ, always any documentation you read, at least in Azure side, always read it from Microsoft documentation, because it's a living document. It's getting monitored or updated frequently by the Microsoft folks or community folks by getting the PR link to the GitHub. And I mean, if you don't find it useful or maybe complicated with the Microsoft documentation, then go to the third-party documentation. Because the third-party documentation, there is no guarantee that whether it's getting updated, what has happened after 6 months, nobody knows that, right? But these play, I mean, the Kubernetes itself, it's a lot of moving parts and a lot of innovation happening in a very agile, in a very quick manner. So I would recommend always check in Microsoft documentation as the single source of truth. And the last one, www.the-akschecklist.com. Right away, you can check this akschecklist.com as the fantastic place. If somebody is complaining about AKS or maybe frequently facing some issues, I'm sure that this would apply for other cloud also. But AKS checklist as a comprehensive list of all the checklist items can be considered for your Kubernetes cluster. That's all I have, and I will share the slide deck. And I had a plan to have some demos, but I thought like 17, 16 points, it's so difficult to run each of this command and show some demos. And hope you found it useful. You can also drop an email if there is something missed out or if you want to hear more about it. And Twitter handle is there if you want to quickly get those slides. I'll put it in my GitHub repo and share the slides. Thank you so much. I'll give the control back to Organizer.
Thank you so much, Mahesh. That was a really fantastic session, and there has been so many comments coming in the chat box. People are telling.
Can you flash it at least one or two if you have time? Otherwise, I don't want to take other.
No, we can take, because anyway, it's lunch time, so we can take questions.
Sure.
So there is one question being asked by Anadi a lot of times, so I would like to show that.
Yeah, just flash it on the screen so that I can see.
Is there?
We cannot update or add more IPs to access the cluster once provisioned, right? Yes, definitely. Yeah, you cannot change the subnet size, so you have to be diligent about what is your size you are specifying for. Yeah, next one.
Next one.
Definitely, I think we are not actually asking you to use only Azure Monitor. If you are starting new with Kubernetes, start with Azure Monitor. It's just go and enable, just click. Grafana and Prometheus, I see some of the mature customers start using. I'm not saying no to Grafana. I'm also a fan of Grafana, and I've seen customers using in production. So in fact, you will find a documentation in case with the Grafana and Prometheus integration also.
Okay, next question is this.
Oh yes, yeah, effect of IOPS when using ephemeral OS for AKS cluster. Not only with the ephemeral OS, when you are creating AKS cluster today, by default you get the OS disk, right? Each OS disk comes with certain limit IOPS. 500 IOPS is the guaranteed throughput for your P10 disk. There is a managed disk which comes with P10, P11, P11, P12. It goes on. Each disk has got a certain guaranteed throughput. So I was referring that by default you get P10 disk. But if you think that your application is very chatty, having a lot of read-write IOPS, then consider P11, P12, something like that. Depends on your requirement.
Okay, so
ephemeral OS also is a new thing which is coming up. You can also leverage that. Yeah.
All right. So,
do you have some best practices as to when to use a normal node and virtual node? There's no, I mean, the question is around when to use a virtual node, right? I think I spoke about this virtual node or virtual kubelet concept. By the way, the virtual node is something built around on top of virtual kubelet. Virtual kubelet is the open source project, has been donated to CNCF now. And when I say virtual node, your kubelet will pretend as like your node, but all the workload will go to the ACI, Azure Container Instances, right? Assume that you have a 3-node cluster, but there is a sudden spike in the traffic. You want to handle the traffic as quickly as possible. Adding a new node would take time, maybe 2 minutes, 3 minutes, but spinning the virtual node by bursting the traffic with 100 virtual nodes or ACI images would be very quickly. Within 8-9 milliseconds, I have demo to customer by bringing 100 plus container instances. These container instances would come from ACIs, Azure Container Instances. So it's not actually running with the nodes. All you are paying is only for the 3 nodes and plus those virtual container instances coming to you. So if you have such sudden burst in traffic where you want to bring multiple instances copies of your login screen or your log aggregation, whatever it works for there. Yeah.
So I'll take the last question for now.
Yeah.
And this is
How to cost effectively manage the cluster logs in AKs. Yeah, this is actually a very tricky thing. And you see, so the moment you see that, I would say start with everything and then start have a kind of a dry run or a drill to look at what you're able to understand from the logs, right? Or what is actually pretty much stable and what is actually useful for you. Because there are 6 or 7 buckets within each of this API server or maybe the kubelets. It actually throws a lot of logs, and then see what is the problem you are frequently you are thrown into, and then enable only certain things. And if you find Saturday Sundays are not used, or maybe you can turn off the logs on Saturday Sundays. Yeah.
all right. So that was a really like informative session, and like so many people have like praised you for the session, and they are looking for the presentation slide as well. So once we get the slide from you, we'll be sharing it with our participants so that they can get benefited more out of it.
Sure. Glad that it was useful, and I tried compress as much as possible. We can have one more detailed session when it required. Thank you so
Yes.
much. Thanks for the
No.
organizer. Yeah.
Also, like
Thanks to
Mahesh,
fellow speakers also.
we'll be sharing the live YouTube link. So once you find time, you can go there and answer to the rest of the questions.
Sure.
Sure.
Makes sense. Yeah. Thank you.
Thank you so much, Mahesh, for joining
Bye.
us today. Thank you. Bye bye. So that was Mahesh Kumar from Microsoft, and with this, we have ended the forenoon sessions. So we'll be heading for lunch break. Actually, it was supposed to be for a long period of time, but there was slight delay in the sessions. So anyway, we'll be coming back for the afternoon sessions, and that will start with the quiz at 1:40. But before you guys leave, I would like to show you a few things. All right. I hope you are able to see my screen. Yes. All right. So yeah. So we are coming up with our another event tomorrow. It's called Azure Fundamentals for Developers, and it's happening tomorrow. So those who want to like get started with Azure and looking for the platform where you can start with your Azure journey. So this is where you can attend the event tomorrow. It's from 11 a.m. IST. It's by Vivek Sridhar from Microsoft. And for the event link, you can go to azdev.confirm.com. The link will be shared in the comment box. And what you need to do is this event is part of Azure Developer Community. So what is it? It's a community spread across India in 100 plus cities. So if you want to attend this event, we would request you to go to the communities page, and from there you can find your nearby communities. Suppose if you are in Mumbai, you can search for Mumbai. If you are in Ahmedabad, or if you are in Delhi, if you're in Calcutta, you can search by the region or the city name, and you can join to that particular community group, and from there you can attend the event. So this is the website, and from here you can register for your nearby communities. Right now we have 100 plus communities spread across in India. So once you register for the event, you will be getting the live URL to join for the session. And this event is like uh, will help you to get started with Azure, and will clear all your fundamentals about Azure. So it's a very good session that you must join. All right. So with this, will be heading for the lunch break, and we'll be joining back shortly for the quiz 2 that will start at 1:40 p.m. All right, guys, welcome back for the afternoon sessions. And yes, we'll be starting with our quiz 2 from 1:40 p.m. And a lot of people would be like waiting for it to start. And we'll be sharing the link just in a while once it's 1:40. So yes, it's 1:40, and here is the link. So the rules remain same, and this is the link. It's https://quiz.confhub.com/quiz2. So the link is also being available in the comment box. So go to the quiz and try to answer as many correct questions you can. And yes, we are considering the time taken also. So try to finish the questions as soon as possible. So let's see what is it. Okay, all right. So we already have 11 people participating. So people who are participating, there is a rule like the people who have already won the quiz one won't be eligible to participate in quiz two. So we are trying to give opportunities to everyone to win and earn credits and Azure exam vouchers. So the top three winners will be getting Azure credits and Azure certification exam voucher. The link is already there on the bottom of the screen and also provided in the comment box. Make sure you are not a duplicate participant attending this quiz. The quiz will be open till 1:50 p.m. and soon after that we'll be uh, inviting our next speaker and we'll be going through other uh, events which are coming in future. So for the afternoon session, we'll be having Mamta Jha as the first speaker. All right, so we have 90 people already participated in quiz 2. All right, so it's 108. All right, so we have 281 people participated. So people, we are left with just 2 minutes for quiz 2. So we are just about to end with quiz 2. People, those who have not participated yet, please do it soon. We already have 380 people participated in quiz. All right, so it's just 10 seconds more. And here we close with our final winners. We will be reaching out to our winners after the conference via their registered email address. Also, guys, after the conference, like at 4 p.m., we have quiz 3 as well. So those who have not won any of these quiz, so there is a chance still for you. All right, so here we are. So we'll be now starting with our afternoon sessions, but before that I would like to show you we have another conference and events lined up for in future. So here are, if you guys are able to see my screen, so this is Azure Developer Community, as just I mentioned some time back. So it's a community spread across India in 100 plus cities, and we are coming with our very first event tomorrow. It's on Azure Fundamentals for Developers, and the event will start at 11 a.m. IST. The session will be taken by Vivek Sridhar from Microsoft. To register for this event, you need to go to the communities page, and you can join any of the communities. But what we would suggest is like join the community which is nearby to you. For example, if you are from Mumbai or Delhi or Hyderabad, you can search for that region or the city and join that community. After joining the community, only you will be getting the live URL for the event. All right. So that's all from my side. And with this, I would like to introduce our first speaker for afternoon session. It's Nipendra Khare.
Hey everyone, good afternoon. Hey,
Hi,
all good? How about you?
I'm doing good. So we have currently around like 600 plus people watching this live conference, and you're the first speaker for afternoon sessions. Before you, we had three speakers, starting with Sayam Bharti, then Ronak and Mahesh Kumar. So now it's your turn. So Nipendra, I would like you to request to share a screen so that you
Just
can
a
present.
minute. Yeah, go ahead.
Yeah, can you
You
share
can
a
hear
screen?
me?
Yes, yes.
Can you hear me now?
I can hear you, but I think there is
Yeah,
some lag.
just a minute. Let me just check if I'm on the right network. Yeah, so that seems good to share the screen. I do have an option right now. Yeah, I have. Sorry, was my bad. Yeah, you can see my screen now. Just a minute. You can see my screen now, right?
Yes, I'll just put it on the screen.
Let me bring actually the slides here.
Yeah.
Yeah.
Okay, so I have. Okay, yeah, yeah, it's live.
Yes, so we still have some time, right? 5 more minutes.
Yes, yes, you have extra time of 5 minutes.
So I'm saying that no, it's still 1:55, correct?
Yes,
We
yes,
should start at sharp 2, correct? Yeah. Okay.
but we can start now because like we thought of like we'll be having some extra time. So yeah, anyway, like you can have extra questions for your Q&A session. That's good part.
Okay. So you want to start now? I have no problem. We can start.
Yes, yes, yes. All right.
Okay.
So going
Sure.
forward, like Dipendra, can you give a quick introduction about yourself, like what you're doing, and with that, you can tell what your session is going to be
Yeah,
about.
sure. Afur, I'll do that. I'll do that for sure. I'll do it for sure. Yeah. Yeah.
Sure.
Just give me a minute. Let me just check if my setup is all good to go. Yeah, so I think we are good here. Okay, sure. Hello, everyone. Thanks for joining in the session, and thanks for KonfHub to arrange this session for all of us. I'm sure that you would have learned a lot with other sessions which happened earlier today morning, and even you'll have the similar thing for the second half today. So, just a minute. Yeah. 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 So let's get going with our session of this, in which we are going to cover YAML tips and tricks for KTS. So my name is Nipendra, and I'm founder of Cloudiga, and I have been in the space of training and consulting for around 5 years now, more than 5 years actually. And we train people on containers, Kubernetes, history of Prometheus, and so on there. Before starting Cloudiga, I worked for different companies and had different roles as system engineer, file system, perf engineering, and support, and so on. So every 2 years, I kind of try to change my career path just to kind of learn or get a breadth of things there. I am also a CNCF ambassador and CK certified as well. I wrote a course on CNCF for Kubernetes, which is a free course on EDX, and it has been taken by more than 150K participants around the world. And also authored the Docker course in 2015. And there's one more course on cloud infra technologies if you're interested to learn about what cloud is, how we kind of get started with the cloud and so on. I would suggest you check out that course, and currently runs Kubernetes and Cloud Native Online Meetup, which is part of this particular event as well. Yeah, so that's a quick intro. So with that, we get going with the agenda, like what we're going to cover now. So I'm going to touch upon some of the basics of YAML first, and then we look at how we use KTS in YAML, or sorry, YAML in KTS. And we look at also some of the API reference of Kubernetes, so that we can see how does the object gets created and so on there. And then at the last, we'll look at some tips for KTS about YAML there. Okay. Yeah, so YAML full form is yet another markup language, and there is there's a spec defined for this. And if you want to kind of check out the spec, maybe you can see the spec on this particular URL, which kind of gives you the complete spec of YAML. Let me open this link here. So it kind of gives you try out different things, write the document, how to read it, and so on. So all the information about the YAML documentation, all about the YAML is here. From the perspective of Kubernetes, which is our main target, we are going to primarily use two things. One is YAML maps. So as you can see that there is a key value pairs, and that's all map is. So here we say API version is equal to v1, kind is set to pod. That becomes your map. Okay. Then we have a list item in which wherever is kind of this hyphen, you're kind of working on a list here. So here we say in the pod construct, we say containers. And here we say in this pod, we have containers with the name myc1 and the image and so on. So this is the image construct for you. So remember you do, yeah, go ahead.
Will it be possible for you to increase or zoom the screen?
It's full, let me see. Is it okay now? Let me just, hopefully, let me just see if I can make it full screen. That would be okay, I believe.
Yes, this is better.
Is it okay now?
Yeah,
Or
it's better.
It's better? Okay, fine. Yeah, I think I think this font is not too black. That might be a problem there. But hopefully it's still visible. I mean, no need to kind of go and read what's there. What I'm trying to convey here is you have these key value stuff that becomes your map. And you have these list here. Whenever you see this kind of a hyphen here, you kind of say that, okay, you're kind of doing a list objects there. So in the pod construct, if you look at, we have containers, and we can have multiple containers in a pod, and that's, we say a list, or the list there. So container 1, container 2 becomes your list there. Okay, the indentation can be done with one or more spaces. So generally, when somebody start learning YAML, we ask question, are we going to use one space, two space for indentation? So there is no defined rule for that. Is that you can use one space, two spaces, but it has to be consistent. That thing which matters there. But no tabs, that's for sure. You cannot use any tabs in your environment. So let me quickly kind of run through one of the YAML file here. Yeah, so hopefully you can see my screen here. Yeah, so here I have a file. The font may be a problem for you guys. Let me just do that. Yeah. Yeah. Hopefully it's visible to everybody. Yeah. So here we have this file called ns.yaml. And as you can see here it's just a typical YAML file in which we create a namespace here. So here we have two spaces, correct? So one space and two space. So I can't use tabs. Tabs is not allowed. So use two spaces. That's one approach. And if I kind of go and apply it, you will see that this is going to work. Then, for example, if I go and now, let's say I want to create 4 spaces, no problem. You can add 4, you can add 6 also. it's still going to be same because it's not changed because it is already there, correct? What you cannot do is you cannot mix and match. So what I want to say is, for example, if I bring it back here, and let's say currently I have two spaces here, I add labels here, and here, let's say instead of 2, I want to make 4 now, for example, 1, 2, 3, 4, and I say env is equal to dev. Now here I say I want to make 2 here, 1, 2. I put one more stuff here. Let's say here is equal to front end, whatever. Now this is not going to work because there is a problem, right? Here I have 6 spaces, here I have only 4 spaces. So if I try to make a change, it is going to give me an error saying that whatever the error is there, right? But the problem was there because we did not perform the indentation at the same level. So if we had used the 6 spaces here, we should use the 6 one here, or I can bring it back here to 4 or whatever. Like I think 2 was there, sorry. So it was 4 and 2, not 6 and 4. But that's okay. I think you got the gist here. Now if I apply, it's going to work. So the main part to remember here, either you can have 1 space, 2 space, 3 space, and so on. But in a given hierarchy, make sure that you follow the same convention. You can't make a change there. So no tabs, and spaces is up to you, whichever count of spaces you want to have. Just a minute. Yeah, sorry. Okay, are we good? Are you able to see my screen?
No, Nipendra.
Yeah?
No, it's not there.
It's not there, sorry. It got unshared by mistake. All good now?
Yes.
Okay, fine. So that's one point to remember, which I was saying, that use only spaces, no tabs, and indentation you want for the spaces, up to you. Now here is one example of a YAML file which I have got from that YAML documentation per se. Now you can see here there is a mix and match, right? So you can see that there is in this particular file we have these lists here. Under the list we can have maps. So you can mix and match there. You can have maps inside the list inside the maps of maps. So all these things are possible within a single YAML file, and it is up to you how do you want to use it. Yeah, hope that makes sense. Okay, now here are some of the issues with YAML which are good to know. So as you can see here is we are defining a YAML here, and in which we are defining a country code here, Ireland or whatever, right? Whatever we are giving here. Now I'm going to, so for Norway we have given no, that's the important part here. Now I'm going to have this YAML file load into the Ruby application. And now what happens is, as I load this particular YAML file with Ruby, and if I look at the output of that, this becomes, Norway's value becomes false. What's happening here is this NO is getting treated as the false condition rather than that string here. So that can be a challenge when you're writing a YAML file and you haven't specified the string specifically. It would treat as a false, and that can be a problem. One more thing here. For example, here we are using a YAML reference here. The idea is that I can refer somebody. I can refer somebody by the, what you call, say, this ampersand here. Like I'm sure you would have seen that. So this is the first line here. This is the one in which I'm saying there's a speaker. Let's say in pointers we say it, right? Pointers and see there, right? So you're saying refer Nipendra as at the speaker, and when you want to decode it, you can say star speaker. So what happens with this? I say star speaker and becomes Nipendra here, right? So all good here, but you can think of some kind of a complicated or kind of a, say, a bit more kind of a, say, advanced or complex configuration here. And if you kind of make pointers like this in YAML or reference like this, what can happen is if you have not cared properly, a YAML file can blow up your entire system, right? So because you are referring via reference, and if somebody kind of put some wrong stuff in your YAML file, and if you're not very careful about it, so when this YAML file get loaded into your system or in your RAM of your container or VM, whatever it is, right? It can take a lot of memory resources or a lot of memory from system, and it can then give out of memory to your system. Just be careful that when you're using a reference, just make sure that you know what you're doing, and just don't apply YAML file if somebody has given you, right? If they kind of had this kind of an issue, it can become a problem. That makes sense? Yeah. But why are we stuck with YAML in Kubernetes in a way, right? So when we saw, okay, YAML is good, it can be very much readable and so on, but there can be a better way, or there would have been a choice where we could have chosen a better way of YAML or something else for Kubernetes. But if you look at here, there is a commit from Joe Beta, who kind of one of the creator of Kubernetes. And this, I have got a reference from his talk. I'm sorry about the YAML. So actually, he gave a complete talk on this, that why is YAML can be a painful in Kubernetes, though we are there now. And as you can see, if you look at the comment here, it says that we should be able to get away with just the YAML parser. This will work for now, though, right? So that's how it is, right? It's like you start something. So when they were building Kubernetes, they need something quickly, right? And they chose YAML at that point of time. And now we are stuck with that, right? I'm not saying it's bad, but it just to be, we should know what we are trying to do there. Okay. But anyway, why we can't use JSON over YAML? Why we should prefer YAML over JSON, right? So we know that, okay, in Kubernetes, we can write our manifest file in JSON or a YAML. But why we prefer YAML? There's a reason for that, of course. First of all, YAML is a superset of JSON. So if you have a JSON file, you can always have it into YAML format. YAML is more readable. As you can see, we have the YAML configuration here and the JSON here. The size of the file is also matter, like as the same font size here. I don't want to kind of do a cheat here, but yeah. So here is a YAML file, and if you kind of expand, it becomes your JSON file, which is a bit large. And as you kind of expand more, kind of have more content, the JSON file can kind of may get too big there. It's more readable for sure, and then you can allow comments in YAML that you cannot do in JSON. So this is why we prefer to use YAML in the Kubernetes manifest, because of these reasons there. Okay. Now, before we kind of get into much of some of the tips there, let's talk about how does we create an object in Kubernetes and how we can reference it, and maybe seeds documentation, understand how you can write a YAML file for your object. So in Kubernetes, as we know that we are going to communicate to a API server. And in the API server, we have this core API group, and we have this other API groups. Under each API group, we have the version here, as you can see here. So this is the core API group. So /v1 is the GA release. Then maybe we can have a group here, API/batch. And here you can see we have the V1 version and we have the V1 beta 1 version. So depending on the feature you would want, you would go and connect to the respective endpoint. So for example, if there's a feature in the beta which is going to come in the next release, I want to try it out right now. So I would go and hit the V1 beta endpoint. Otherwise, I'm okay with the V1 release and so on. So every resource in Kubernetes, like pod resource, right? It is under certain hierarchy. Like to create a pod object, I need to kind of go to /API v1 and then pods. To get deployment, I have to go like this. So these are predefined objects are there. And if you kind of look at the API reference documentation of Kubernetes, right? So if I go to API reference, yeah, so one page API reference. Yeah. So if you look at here, in the API reference documentation, we can find out like a pod object. It's under the core API group, right? So core. So we need to kind of hit a certain endpoint to create an object of that type. Now, why I'm talking about that thing right now, because it kind of relates to our YAML kind of understanding there, right? So as you can see here, we have a deployment configuration file here. And in this configuration file, we are defining this spec configuration, right? So let me just go back to the slide a bit. Yeah. So in Kubernetes, when we define a section of spec in that. So spec becomes your desired state. So as we know that Kubernetes always try to make sure that at any point of time, your current state of the applications or the cluster is equivalent to desired state, right? So when I'm creating any object in Kubernetes, we are going to define the spec. So a spec is here for the deployment configuration, and then we see one more spec for the pod configuration. It's a template pod configuration here, right? So we define the spec that's again for the pod. So let me, if I go and apply this particular YAML file, so this would be created now, and this information is sent to the API server of mine. And if I look at it, would be there now. It's still getting created and all that. That's okay. So if I do get sort of deployment name there. If I do a get deployment, K for kubectl, just to give a short form there. And if I say -OYML, so what you see is once I have applied this particular pod or a deployment object, and if I look at its output in a YAML format here, there are two sections we can see in the output there. One is the spec. The spec defines the desired state what you have. And then we have a section of status. So when you create any object, this object gets created in the Kubernetes cluster, and the status is the current state of the object. So at any point of time, I'm going to make sure that I check the spec in the status section and see both are mapping or not. So that is what we are doing it here in this YAML output of any object. So you define any object, you do a get on that, and if you see the YAML stuff on that, you will see this status option, which is going to give you the current state of the objects, whatever you might have there. Okay, yeah. So let's now get into some of the tips there, which we can learn about YAML stuff on Kubernetes. So first tip is you can basically write multiple YAML files into a single file. See, suppose I want to deploy any application, I need to write the deployment object for that, service object for that, ingress for that, and so on. So instead of having all of those things in a single file, in a different files, we can have them in one file. So the way to do it is you just kind of enable these 3 hyphens in between 2 YAML files, and it becomes separated. So that way you can basically create a large YAML file which contains multiple component of it, deployment, service, ingress, storage, and so on, whatever, and apply them at once. So that kind of would save, basically you can say that this particular YAML file belongs to this complete app. I do not have to kind of make these or kind of understand these things separately or manage them. Of course, there are more better tools are available like Helm, and then we have a customized tool also. But for the YAML perspective only, you can combine multiple YAML files together. That's the tip 1 you can think of. Second tip is use codes whenever you are dealing with like the things like Norway here, that where you kind of give a value of an object to no. Better you use the codes there. Otherwise, you would get this kind of error saying that the value is false and then I cannot continue. So if you apply this particular pod configuration, it's going to fail. So better you basically use the codes with the values here, with the string here. Similarly here, if you don't specify the code in the version, then this becomes the integer, or what you can say, float there, 10.3, correct? So if you want to use a string, to make sure that you apply the quotes there. So whenever you are in doubt, use quotes. It doesn't hurt. Yeah, then we saw about the third YAML configuration or third tip here, which we kind of discussed earlier as well. You can use references. So for example, in a deployment object, as we know that we define these labels to our pod configuration, and we have a selector here, and that selector is generally matched with the label what we have given, right? So instead of writing these labels again here, I can basically give a reference name here, labels to match, and then I can basically put a reference of that particular those labels, just like with the star and the labels to match. And that way I can be sure that my replica set in the deployment would select the right pods which I would like to. This is tip number 3. Then there is a tip number 4. I mean, using which you can so you can use some YAML linters or IDE plugins to make your life easier. So of course you write YAML files, but you may want to kind of see if my YAML file is correct or not. So simply you can kind of go to your this YAML lint file or YAML lint, right? Yeah. And there are some other tools that are available for sure. So here you can copy paste your YAML configuration and check if that will get the simple one namespace one maybe, whether that YAML file is good or not. As you can see that it would work. It looks fine, but for example, if I change the tab on the spaces here, it's going to give me an error. So you can use some of these tools to verify whether the YAML content what you have is good or not, right? That's one of the stuff you can do. Then we have one more interesting tool called YQ. And with this YQ, like I'm sure you would have heard about JQ. So similarly, we have this tool called YQ that you can install locally on your workstation, and you can do some kind of checks there. So I've done that already in my setup here. So for example, if I look at YQ and let's say, so there's a help here. So primarily we can use this eval option there, or short form is E here. So you can use YQ eval and see if your file is good or not. So for example, if I say YQ eval my NS file, right? And this kind of looks fine, but let's say if I change something here, let me change this time here. It kind of gives you the error. So you can kind of do a local check if you would wish to. Then similarly, you can basically update some parameters also with this YQ tool and get a new YAML configuration. So for example, if I want to change my tier to, let's say, backend, just for an example. So I'm just going to say YQ eval, and I would put dot metadata. I'm getting in the right dot labels dot tier is equal to something and the file name. Yeah, so you can see that it kind of spit out the YAML file for me, so I can basically get this output. What I want to kind of see here. There's one more thing which I want to show you. Just a minute. Yeah, you can also convert YAML into a JSON. So whenever you want to have, you can just say YQ, and then you can convert into a JSON format with this YQ tool. So YQ tool can be available on a local workstation, and you can play with it, right? Next is you can use some of the IDE plugins that can help you in doing the YAML management for your Kubernetes there. So what I could do is I have basically, let me see if I have that Visual Code. Yeah. So I have Visual Code installed here, and let me create a file here. Yeah, so you can basically go to Visual Studio Code and you can install the plugins there. So where did that plugin option go? Not editors. Yeah, so you can install the extensions here. So like I have done the installation of extension of this YML, and this YML plugin for Kubernetes is from Red Hat, I believe, and you can basically then easily create your YAML configuration for your Kubernetes cluster. So for example, if I go and create a new file here, so let me, yeah, sorry, I'm just not very used to this thing. Yeah, I'll just do it like that, maybe old way a bit. So here if I, because I already have the YAML plugin installed for the VS Code here, I can say if I say API version here, and okay, let me just give the file name first. So let me say pod.yml, for example. Yeah. So now if I say API version, yeah. So as you can see, automatically kind of giving me the completion of that. I can say v1, and then if I say kind colon, then if I say pod here, you can take, I'm kind of getting the configuration here, pod, I can say deployment, I get deployment here. If I say pod, I can select pod. And as you can see that you are getting all of these configuration of YAML automatically to you. So you can basically then, okay, now it's kind of giving me, yeah. So you can kind of make a change, just a minor change here, and you can deploy your pod into your cluster. So apart from this plugin, you can also install a Kubernetes plugin, and you can have a complete workflow of creating your YAML configurations for the objects, and then deploying on the Kubernetes cluster directly from the VS Code itself. So VS Code seems to be a very good tool for doing all this purpose, like creating a YAML, deploying to Kubernetes, and all that thing. Yeah, similarly, you have plugins for IntelliJ as well, and maybe some other IDs also. Yeah, so I think, yeah, that's all from my side, and I think we kind of finished exactly in half an hour. I can take any questions now, if you have any. How can we get questions here? Let me see.
Yeah, Nipendra, I'm showing some of these questions on the screen.
Just a minute. Yeah, I can see that. Yeah.
Here's the first question on screen.
Is there any UI tool for YAML that makes it easy? So I think we saw this tool here, VS Code, that you can think of as a UI thing per se. But because YAML is a kind of a configuration thing, right? So you need to write the configuration of your application in some way or another way, right? So you have to do that. And there might be some tools which may be there which can help you. For example, if I say I want to create a pod object and it can create a sample YAML file for you. That's what it has done right now. But I'm not aware if there is a particular UI tool because it's very good to drag and drop and make it. I don't think so. That's kind of needed per se. Yeah. Yeah. Any other questions? Can we separate configuration based on environment? Yes, good question there. Of course, you can do that. So not just with YAML by itself, though. Like if you want to, for example, like we have parameterized the port number here. Like if you can see my screen, are we sharing my screen? Yeah. So here, as you can see here, we can have this port variable here. Now, this you can, like in an old way school, you can do sed operation, right? Sed or awk, and you can update that. So that's a kind of a challenge which becomes very, as you kind of start using Kubernetes in a day life, right? You might want to kind of do some kind of templatization there. And that's where the tool like Customize or Helm would come into play, where you would take the configuration or exact values outside of the template or outside the main configuration, and then you can apply them on the fly. So not just with YAML. With YAML, you can just basically have to use standard awk, or what we saw with the example of that YQ, right? With the YQ tool, I can do that. So these kind of tools you can use here. But if you really want to kind of get full kind of customization there, or full kind of complete tooling around it, then I would suggest a tool called Customize. And I have done a meetup earlier in our meetup group. So if you want to check it out, you can get a video of that. And then there's a Helm package manager also, which is a complete template based configuration which you can use there. Yeah, Shivram. Yeah. And then basically in that configuration, you can define, okay, this configuration for dev, this for QA and ops, you can do all that. So check out my video on the customize, you should get the answer. Yeah, any other questions?
So I would take one last question from him.
Sure. Yeah, as an error, what you can do is, what I mentioned, that you need to kind of go and check on that. That YAML lint or YQ, or otherwise I don't know what tool you use for typical app development. I typically use Vim, and again kind of because I don't kind of write YAML files day in day out. But in the Vim tool, I can say a tab is equal to tab is equal to 2 spaces. So I can configure in my editor, say when I press tab, it actually puts 2 spaces or 4 spaces, whatever I would like. And that way I can get rid of this problem. Hope that makes sense, Hemant.
All right. So with that, I think we are good. So Nipendra will be sharing the live YouTube link with you so that you can go offline and answer if there are any other questions.
Sure.
And also, thanks a lot for joining us today and sharing your experiences.
No worries.
Awesome session. So Nipendra will be, we're planning to share speaker slides with our participants.
Yeah, I'll do that. I'll do the share, yeah.
All right. Thank you so much, Nipendra.
Thank you. Have a good day, guys. Happy learning. Bye-bye.
All right. So that was Nipendra Khare. And next we have Reenu Saluja from Microsoft. Hello, Reenu.
Hello.
How are you?
I am doing good. Thank you for having me in this conference.
Thank you for joining us and accepting to give a session here, Reenu. We're really glad. So, Reenu, would you like to give a introduction about yourself, like what are you doing and what your today's session is going to be? Meanwhile, we'll be sharing a screen onto this stream.
Okay. Myself, Reenu Saluja. I'm part of Commercial Software Engineering Group within Microsoft. And here I'm working as software engineer. We work with the customer to build their Epic solution. And these solutions, they generally build on Azure and using open source technology. And as an open source technology, Kubernetes these days is having a lot of focus. So that's why my today's topic is all about how you can deploy your application from your local environment to cloud with secretless. Secretless is you need not to store your credential, your configuration information on a specific file on your local machine. So this is all about today's topic. And during session, will have a bit more detail. So as I said, today we are going to talk about secretless deployment from local to cloud. And what are the various things that we are going to use today is, one is Azure SDK and another is Project TIE. And both together will help us to deploy our application on Kubernetes. So it looks like there is a lot of cool stuff that we are going to today. So let's talk about today's scenario. So as I said, we are going to have three main pillars. One is Azure SDK, another is Project TIE, and third one is AKS, like your Azure Kubernetes services. So just have a look on this slide. So before and why this slide, before get start into the detail of each and every component, I thought let's first share about the developer productivity. So our main focus is to improve developer productivity, and that's why we are working closely with the product group. And a couple of years we looked at the landscape of Azure SDK, and we discovered that there is spread out of this is spread out of across so many repository, and so we had to think like these 1,000 repositories using 1,000 of different various type of languages, services, and it's quite too hard keep track, and we don't have consistent experience across the board. So overall it's mean loss of productivity. So on bottom side you can see this is the new things after revamping of the Azure SDK. And why I'm talking about this SDK today, because in SDK, we do have several components that we can use during our session, but the main one that I'm going to highlight is the identity part. So just to give a brief, like if we want to have consistent CI/CD pipeline as well as consistent packages, and these packages are going to deliver to all mainstream packages. So in bottom line, our aim is to go to something which is more consistent, more predictable, and also there's a lot of design guidelines that we had to follow. So if you want to get deep dive, you want to use those things in your project. So this is an again open source. You just go ahead, AKMS Azure AZ SDK. There you can get more insight, and specific component that I would like to highlight for today's session is the identity component that we'll are going to explore today. So we can use Azure SDK and tie together to build secretless application. And by secretless, I mean to say only secret that is going to be stored is in a key vault. So local development as well as the cloud development, you are not going to store or having to manage your own service principal. I hope everyone is aware of the service principle. And so we can do that is using the Azure Identity Library. And now I'll go back to slide number 2, that is all about the Azure Identity Library that I'm iterating again and again. 1 second. Yeah. So this is a glimpse of Azure Identity Library. So in local, we are using Azure CLI for the credential that you already having, and in the cloud we are going to use manage identity, and in other secrets like setting store and key vault, that is also used here. So how that look like is this is so new Azure Data Identity Library provide us with this object and this class called token credential, and we have a set of classes that is drive of that, and from the token credential, and token credential basically get token. And from a developer experience, if I would say, you have Azure CLI credential, and also you are using VS Code credential, you are using Visual Studio credential, and as we are using different tools or different set of credential that we need to use in our application. For example, if I'm doing development, then for Java, if I'm using IntelliJ, then I need to use IntelliJ credential, for example. So so for .NET, we have these 3 environment variable plus interactive browser controls. So a lot of credential type of available that you can use in your application. So what is mean is when you already logged in into one of these tool, you will be able to use that identity to authenticate to Azure. Like if you have Eclipse, in Eclipse there is an option to authenticate to Azure. In similar way in Azure Studio, if you have already authenticated, does it make sense to have another configuration layer in between to capture the information and make your application up and running? Do you need to store those data? And for example, if you already have Azure CLI, and if you have already done AZ login, you assign role and responsibility or RBAC to your service principal to your account, then your access, say, to underlying services. For example, if you are going to use Cosmos DB, you are going to use Blob services for your application, those will automatically get access. And in production, if you are going to use the manage identity. So this is a quick code example how Azure identity look when we have various credential equivalent to our Azure credential. And what does it mean? Like in Azure, we have client underscore ID and client underscore secret and tenant ID, and these are the environment variables. So once you have already logged into Azure CLI or using your IDE, so these are the configuration that is getting stored. So in a set of developer, these is already available, and so it's an opinionated way to build. And it's a chain token credential, which you can see on the next line. So I would say this is the, and again, the what is what does it mean is the custom chain credential. So if you want to use the Azure credential, you want to use your own chain, you want to build it. So you can use manage identity credential here, and then you use your CLI, whatever you want to use. And then in similar way that you can see on the board, in similar kind of lines will be there, which will capture the information from the CLI, and it will make a chain of the manage identity credential. So in sequence, what will happen, as I told, we have environment variable, we have uh, also our ID variables, and some configuration information. How will it make change? So which one to pick first? So what will happen, it will first try to manage identity credential. If it fail, then it will try Azure CLI credential. If it cannot find it either and it still fail, then it will go back to the classic way to file either if you have a key vault integrated with your code. If there's a key vault integrated, then it will try to pull the secrets from there. And if you are using another kind of secret client, then that is going to be the last option, and through which it will try to get that all information. And on top of that, if you are going to use auth token or token based authentication, then it accept the token credential as well as one of the parameter in the construction that you can see in the last line. So it will get those, and it will create the client, and finally that client you can use across the board. So you have various type of credential store in various type of environments. Now it is consolidated, and it will try to use the best one, which is best fit your application. So now this is all about Azure Identity library that we are going to use. So let's talk about the application or the sample that we will explore today for the secretless deployment. So this is an sample application that I have took today, and this is Mimi Analyzer. So as name signifies it's combination of two. One is Mimi's, another is Analyzer. So this is just an sample application, and use this application. We are using Azure SDK libraries as possible, and also this is an open source project. If you want to explore it, you can directly go there, and you can pull and have a look in the code. At high level, what this particular library is doing, it is picking the memes, and it is trying to find the sentiment behind these memes and try to highlight, like you can see if you are in yellow, if you are in green. So now at high level, in technical terms, what I would say, if we have a new library coming out and we could integrate with the application, and one of these library, because building such kind of application, this is not only one library that we are going to use. At high level, if I need to extract the sentiment of a meme, then I need to have text analytics in it. I'm uploading the images, then obviously a blob storage is coming into picture. And because if this application is going to be used by multiple users, so there may be a queuing solution that will take place. And also after extraction of information, if I need to store the persistence data, or I need to set in configuration information, whether sentiment, if result is like 80%, it is green for me, or I need to change the configuration, it need to be like 95%. If it is positive, only then it is going to be green. So such kind of information for positive or negative or neutral memes, we can store into any kind of databases as well as, or any kind of like Cosmos or table storage. So this application is using a number of things behind the screen. So for all these components, we are going to have some keys, and then there is some specific URL, some secret information that we need to store. Imagine if we need to store all these kind of information on a configuration file, and we have 4 or 5 of environment, then for each and every environment we need to change it. And sometime what happens when developer they have created in .env file in which they have stored all these variables information, and if they are not using GitHub, and I have seen this happening many times, without git ignore, they commit the code and everything is on public, or if still it is in your private repo, it is committed, and anyone can see this within your organization, or the specific person who is having access of that. So that's a risk involved. Even if you remove that file, still it is getting stored in the history. So that's trail is quite hard job to clean. So that's why, can I have a deployment or an architecture of this application which I can follow, in which I need not to store any kind of this information. So what is in high level architecture? On screen you can see this application is like first with app configuration is reading the data, then someone is posting the image. After posting the image, image is getting stored to blob storage, then a queue message is getting added, and .NET Core services, they are actually working with the AI services for the extraction of the text from the image and getting the sentiment, and finally data is stored in a Cosmos DB, and for that metadata is also get stored into table storage. So these kind of data provider is used in this application. Finally, reverse path is to sending the users acknowledge that what is the actual sentiment. So the reverse path that you can see, that is number 8. It is client sync queue message, and then it trigger function, it reply back. So at high level, it is also having some APIs. It is having Azure function on top of that. So the complexity in terms of the number of services, and this is not a single solution. Any application that you are going to build for production, anyway, they are going to use at least these kind of services, any databases and blob storages, queue functions, or these are the bare minimum requirement these days. So what about if I need to have secretless in this application? So what I will do, let's quickly jump to code, and from there I think it will be easy to understand how this happens in the code. So this is Visual Studio Code in which I have opened my application. So first, let's talk about the main component, that is my client.cs file. So this is an claim how we are doing secretless in this Mimi Lizer code base. So this is an identity class, and there is a chain token credential which is getting called, and there you can see we have different type of data provider in this, and these data provider is getting initiated, and it is getting read all the information from the configuration part. So we can, as this is get change, get credential is happening here, and it is this is a client, and this is used across the board with various component, whether this is my Azure function or my API layer or various things. So we can reuse it, and I'm saying if I want to reuse it, I need to manage all the identity and secrets which this particular layer is using. And now let's have a look on the other slide, that is how my data providers is going to act in this scenario. So one thing I missed is like this is the managed identity chain. I think this is same code which we had a look during our the PPTs just few minutes ago. And now let's have a look in the client part. So when I need to set up a new client, and there I have various provider. One is my data provider, another is my messaging provider, and my configuration client, my blob service. So I need to initialize based on my configuration, and I initialize this all these credential with basic app setting. And if I need to ship it to production, because these are part of configuration, and at least in this file I haven't hard coded anything, I'm good to go from this service side. Now we are using queue service also. In queue service it is going to be similar kind of thing, in which we have also initialized the client, and this is going to async call my client service, and there I need not to log in, I can reuse my existing stuff. Then we had two provider. One was for Cosmos DB, another was for table storage. In Cosmos client also you can see we inside the Cosmos provider, we have no secret in this. When I want to get my Cosmos key, Cosmos officially does not support Azure trajectory or oath type kind of token. So we need to store its specific secret, and I don't want to store that secret into a part of configuration or hard coded somewhere. So we are using appropriate permission for using the service principal, and that's how this and here I will pass all the key information, and with configuration it will get the required detail. Now I have one more file as part of the configuration, and there you can see here I have hard coded the detail or the configuration environment configuration variables name, that is like my storage connection string, my SignalR connection string, Azure Service Bus, messaging type. So and this is, you can see this is part of my startup.cs file. So everything will be get boot up from the Azure key vault from here. And this is, there you can see I have configured key vault. And sequence you already know how does it look. In the last, if it is not able to find from your environment variable and local configuration, it will read the key vault. So, and then we have this environment. In environment, you can see I have specified these base name and others. And from there is no specific connection string which I have specified here. It will automatically trigger either from the startup CS that I have provided, or in CS it will just read the name and it will get initialized from key vault and other places. Now another component I will quickly go to that as well. That was the project tie. What is project tie? Project tie is this, and now this is again an open source project, and this is the core component that will help us to do the deployment. So, and why this project? That let me give you a brief. When we thought we need to deploy this application to production, and we need to do for inner loop deployment right here, and specifically for the Kubernetes, we know that to go to do Kubernetes, we need to first containerize my application, and then we need to, and if we are after containerization, again there are further steps that we need to have Docker compose, then finally deploy. And also you already know, build it doesn't mean that for that it's just a simple command. I need to create few YAMLs file for that, and for each and every stage modifying those YAML files for developer it's quite hard. Reason being, they are not familiar how Kubernetes work, and they don't know how scaffold exists, and how these tools exist, and how these tool actually works behind the screen. So being a developer, it's quite hard. So this project TIE is going to simplify those specific thing, and these things are these commands. So using these commands only, you can directly deploy your microservice based application from dev to production or various environment. So as I show you the code, in code you are not going to hard code anything, you are just specifying the various parameter that you are going to use. So let me give you brief about all these at high level, what these command is going to do. Like, first task is to containerizing the project. So what we will do in project TIE terms, we are not going to create any kind of Docker file. Although it's optional, if you are going to provide the Docker file, it will directly use that. Otherwise, if you are not going to provide the Docker file, then what will happen? It will read through your code, and there in application configuration we have provided MCR Microsoft.NET, and SDK is 5, and in recent upgrade, it will automatically scan your project, and it will see what are the required configuration for this project, and it will try to build a similar kind of file, that is our Docker file. So once things are containerized for your project, and let me quickly show you one file. Sorry about this. So let me quickly show you in my project. So what is this sample file? 1 second. So we do have this dockerfile.env. In this we have used this. So if because we are using the latest one, it will scan all the things. If you are not going to create this, it will automatically build for you. Next command that we are done with the containerization. Then we have few other commands, like you need to start the service, you need to debug, there is watch files. For that, what we are going to do is, these are the set of commands. So main command is TIE run, and with TIE run there are various switches that you can use. Like for debug, there is minus debug, minus watch, and these are the step-by-step command. These will do almost each and everything for you, and you are not going to create a single YAML file. There are few things as part of configuration that you are going to create, and these files are just a quick look in the file. One is my run.sh that I have created in run.sh. You can see this is again a TIE run command, and in this we have specified the switches on which environment. So based on environment, it will hit the key vault, and it will try to generate the configuration file. And since it does not work along, so that's why behind the screen we are using another shell script, and in this shell script we have defined this is the shell script which I kind of YAML it need to generate. So once we have done this, then there is one TIE-ML. So this file, you can similar the files that YAML file that we use to get things deployed into Kubernetes. But this is very simplified version. There you can see what are the Azure function that need to get, and also there is details about the ingress and other things. And one is for, like, there was one is TIE-ML, another is similar way for production. You are going to create similar kind of thing, and it will for production you are also going to spy which is going to be a service, which version it need to use. So in terms of less number of tool, earlier that we identify 3-4 different tools at least you need to use for containerizing and deploying your application in the production. But now it's not the scenario. It's a single tool, and only one command with different parameter that you are going to use to have this. And on the last thing that I would like to have is just a glimpse of the project TIE. So this is the project TIE. It's an open source repository, and it's quite easy to configure. And as it is a developer tool through which you are going to develop, test your application, which is microservice based. And also it helps us you to migrate, and you are not going to store any kind of configuration in your project. So everything either is going to be environment, it will automatically pull, it will create the YAML and deploy it to the requirement, to the production environment, or you can have a key vault configure through which it will do everything for you. So I think keeping time in the mind, that's it from my side. And I think now we can have a set of question if there is. And yeah, one thing I would like to say, like Azure SDK, Project I, and these things are open source. So if you have some feedback you want to contribute in these projects, then I'm happy to help, or you can directly contribute this to GitHub repository, and you will get a reply. Or and there is list of upcoming features as well. Now, any question for me?
Yeah, Reenu, I'll be showing some questions on the screen so that you can answer.
I can't see any question.
Yes, here's the first question. You want to see?
Yeah. We can use language API by Azure Cognitive Service for Memelizer. Yes, as I said, it is the text analyzer. So this was one sample application that we had created. So from image it was extracting the text. In similar way, you can use different language APIs. Like we are also working on the Hindi language, and apart from there are various language which is already supported by Azure Cognitive Service that we can use. But this application is a sample application. Currently it is using only English, but yeah, we can use others as well. And this, again, I said Memelizer is an open source. You just extract this project and you are good to modify. So instead of simple sentiment analysis and text extraction, you direct it to various other services as well.
All right. So here's the next question.
Who does not have a cloud? Okay, for a dev team member who does not have a cloud account created but still want to develop and test using Azure Key Vault, how it is going to work? Okay, so for having Azure Key Vault, definitely you need to have one account created. Yeah, one thing is each and every developer obviously is not going to have account on cloud. That is going to be very costly. So that's why what generally organization do, they create a service principal, and this service principal is used across all the developers. And this service principal, they have restricted access. So as per the organization policy. So that's the right way, but you need to have at least one cloud account in which you are going to configure your service principal.
All right. I think that's all. And Reenu will be sharing the YouTube live link anyway with you so that you can go offline and answer the rest of the questions.
Yeah, thank you so much. Thank you so much for having me here.
Thank you so much, Reenu, for joining us today and sharing your experiences. Like the session was really informative, and we'll be getting your speaker slide as well so that we can share it with our participants.
Yeah, sure.
Thank you, Reenu.
Thank you so much.
All right, so that was Reenu from Microsoft. Next, we have Mamtaja. So, hello, Mamta.
Hi. How are
Hi.
you?
I'm good. How are you?
Yeah, I'm doing good. Thank you.
Awesome. So, yeah, Mamta, like it has been a really long day, and we have so many sessions, really
True.
good speakers, and now it's your turn. And so participants, those who are watching, like I would like to tell, this is not the first time we have Mamta as a speaker for our conference. Like she has been a speaker for cloud community days as well, and our participants really liked her session. So yeah, Mamta, I would request you to share a screen
Yeah,
so that I can
yeah,
present
sure.
it. Yes. Can you
Confirm,
share?
please.
Yeah, it's there. So yeah,
You
it's live. So you can give an introduction about yourself, like what you're doing
Yeah.
and what your session is going to be about today. And then you can carry.
Yeah, thanks a lot. So, hi guys. Good afternoon, everyone. So, I am a founder of Tech Scalable, a company which is into training and consulting in cloud and a few niche technologies like machine learning, AI, DevOps, and all. I've been working as an enterprise architect for 9 years, and in this IT industry, I have spent around 15 years of um, the entire journey. I have done quite a few certifications in various cloud, and my forte is CI/CD. And these days, because Kubernetes is one of the trending technologies, I majorly work on Kubernetes and containerizing the application and moving them into the cloud environment and running them in Kubernetes. So my topic today as well is about how to monitor or manage the entire AKS cluster which we have. So I'll be showing you varied varieties of AKS clusters. I've set up 2 clusters. We will see how we can monitor our containers well with the help of tools like Azure Monitor. And in Azure Monitor, how do we integrate Prometheus monitoring solutions so that we can have more a better way of monitoring. Prometheus is an open source solution, so we would be learning a bit about it as well. And the configuration part, where in which file, what do we change and how it works together hand in hand, that we would be learning. And end of the session, if we have any questions, we would address that. To start with, let's understand AKS cluster, which we have, out of which the master node, which is the control plane on the left hand side of the screen which you're seeing, that node is managed by Azure. So that is not visible to us, neither the processes or the system processes which are running on that particular node is visible to us. On the right hand side, which you see is called as customer managed, those are the worker nodes. They are designated as first worker nodes, and they are the ones which actually host the actual application workload. We are already seeing a set of processes being denoted over here, like API server is there on the master side, which handles the API calls which we make. Rather, it could be via the dashboard, it could be via the CLI command, or it could be via some other application like a CI/CD pipeline. Then we have a scheduler, because when we are talking about containers, and containers are not that as stable as virtual machines, they are born to die, as people say. So when we have a bunch of containers, we can't confine ourselves to a single host machine. And that is when Kubernetes comes as a rescue for the containers. When we have a bunch of containers to run on several set of servers, we have Kubernetes solution making sure that whatever is a desired state configured by us for any of the application, Kubernetes would maintain that. But when we have several set of nodes, as you can see, I have 2 set of nodes here, some decision has to be made to decide if you are planning to host a container of application, on which node would it get scheduled. So scheduler does that. HCD is the complete memory, or you can say the configuration map of the entire cluster. You have controller manager, which is like the brainy block inside the control plane, which takes the responsibility of managing the entire cluster in desired state. On the right-hand side, on the worker nodes, we would have a kubelet, which is like running as an agent. You see, that's the one which is actually getting messages from the master node. Container runtime, we are using Docker in case of AKS cluster, which has the ability to create containers. So containers would be created by Docker and managed by our Kubernetes. kubeproxy stitches up the data plane path for the application container. So in case of Kubernetes, we normally don't host application workloads on master. We only host the application workload on the worker nodes in the cluster. Now, when we have several application containers running in the cluster, it would be very difficult for me to monitor or have a proper status check of all the things which is happening. So normally what we do, let me take you to my cluster, and I have a cluster configured. I have configured Azure CLI in my laptop. This is my laptop's terminal, Max terminal, and kubectl get nodes would show me the number of nodes I have configured in this cluster. I have a 2-node cluster ready. And if I want to check what all resources are running in my system namespace, I can even do that with hyphen and cube hyphen system. I have to specify the namespace, and then I say which namespace. So Kubernetes system processes, which we saw just now, they are running in kube system namespace. So you would see few.
Sorry
Is
to
there?
interrupt. Will it be possible for you to zoom a bit?
Yeah, certainly.
Thanks.
Now it's fine.
Yes, yes. Thank you.
Okay, cool. So here there are some networking containers which are running, which help us to stitch up the networking, because when we have multiple nodes in the cluster, they need to communicate on the same network. So it stitches up a flat networking for the entire cluster. I have DNS containers running, which help us in doing the DNS resolution of the application workload, which is actually running in the cluster. We have the kube proxies running, one in each node. This one is you can think it is like an inbuilt metrics monitoring solution, which helps us to monitor a set of things. So kubectl top nodes, if I can find some set of data about the memory and the CPU utilization. It shows me how much of bytes of memory utilization is there. The percentage is given over here. Same way on the pod level as well, I can find out the details. So metric server is not that good. Why? Because it is an in-memory monitoring solution. What do you mean by in-memory monitoring solution? If I have a container running of metrics, if you can see here, there is a container, the pod running of metrics, and it is running on one of the nodes in the cluster. Let's see on which node it is running. So here with -o wide, the wider option, you can find on which node exactly it is running. It is running on the first worker node. And this worker node has a metric server running. It's not that it is only collecting data about that particular worker node. Let's understand how it collects that information. So if I have 2 worker nodes and I have 2 worker nodes like this, and I have metric server running in one of the nodes in the cluster, it is not that it would be collecting data only for that particular node. Metric server is running as a pod in this particular node in the cluster in a highly available way. In every node, we have understood that there is a kubelet which is running. So every node is having kubelet. Kubelet has an inbuilt component inside it called a C advisor. And here as well, you would have a C advisor. C advisor's work is whatever containers are running in a particular node in the cluster, which are wrapped up by pod in the world of Kubernetes, it would grab the matrices about those pod and it will have it for itself. So this guy's responsibility is to collect the data, and this guy's responsibility is to collect the data for this particular node. Metric server grabs the information from this and is showing us the data. So if I have 10 nodes in the cluster, it will show me the data about all the nodes in the cluster. And that's the reason if I do kubectl top nodes, it is showing me data about both the nodes in the cluster. It's not showing me the data about master node because master is not in our control. It is a managed Kubernetes service, AKS. So we don't see any information about the master node. This data would get lost in case the metric server pod goes down and comes up. It has to recollect the data and have the data again populated for itself because it is an in-memory database and it doesn't have that data which is present with it in a persistent storage. So in case of containers, we have some set of drawbacks like it can't persist its IP address, it can't persist its data. The read-write layer inside the container is ephemeral in nature. So normally we mount a volume inside the container so that we can persist the data which is residing in the container. So here, if we are using an empty directory type of solution, my data inside the metric server would not be persistent. So what we do, when we are creating an AKS cluster on the portal itself, let me quickly go to the portal. So this is my portal. I have set up 2 clusters. And in this cluster, And in fact, in both the clusters, I have enabled Azure Monitor during the creation of the cluster itself. Let me quickly show you how do we do that. So if I type Kubernetes here, or here, if you have recently you type Kubernetes here, you would find the first option which comes is Kubernetes services. If you click on add and say add Kubernetes cluster, I'm creating a new one. In this, you can choose an existing resource group. Let me quickly choose this. Give any name to the cluster. My intention is to show here integration section. Do you see this? Azure Monitor. Azure Monitor gets integrated. There are a few additional services which can be integrated with AKS cluster, and one of it is the container registry and another is the Azure Monitor. So here you can say that I want to enable the monitoring, and you can select a log analytics workspace. In case a workspace is existing, you can choose that, or you wish you can create one. So this way, while creating the cluster, I have chosen enablement for the container monitoring, and I have chosen a log analytics workspace. Let me take you back to my Kubernetes services. I'm just not saving the data which I had entered. So here, if you look in this AKS demo cluster, I have monitoring section, and in that there is an insight which is showing up the data about the cluster. This data is available via Azure Monitor to us. It shows the node CPU utilization, the memory utilization, the node count, active number of pods which are running inside the cluster. All data is visible over here itself. How many are running, how many are pending, what's the status of the pods, how many succeeded, how many failed. Many a times when we are running a pod as part of a job, then in such cases, my pod status can be either a success or a failure. So in such cases, we can have this parameter also getting populated. So this information is like a permanent information. I would not lose it because it is not that it doesn't have a persistent storage, right? This is a persistent data which is available for me, and I can anywhere come and check the data here. So here cluster level data is there. If you see, I have node level data also. Here you can choose the matrices which you want to select, and you can choose the node about which you want to get the data. Here it would give entire data about it. What is running on whichever node, it would show you the percentage of utilization of it. How many containers of it is running, that is also shown over here. How long it has been up and all other information. Same way, controllers also can be viewed. Containers can be viewed separately. These are the controllers which are running. So what happens if I just deploy a kind pod, my application can't be guaranteed to run at every point in time. And if I don't have a controller associated to my application, there's no one who is sitting and monitoring and making the self-healing, like recreation. If my application pod goes down, to recreate that pod, that action is not taken. So these are the set of controllers which actually take that action. So we are getting data about them as well. And per container data is also here. Deployment is in preview. Deployments can be viewed from here. So you have good amount of varied varieties of information over here. Which deployment is having how many containers inside it, how many pods inside it, what's the state of them, are they in ready state, are they not in ready state, are they available to be served the traffic. All those status can be seen here, and here it specifies the namespace as well. In my cluster, I just have two namespaces. If you do kubectl get pods and try to look the pods which are running in the default namespace, you would find that I have run front-end application. There is a Redis master and a Redis slave combination. I've run this, and there is a Nginx deployment also running. So there are two different websites running. There is a guestbook PHP based application backed up by a Redis master and a slave that is running. And there is a Nginx deployment, which just says welcome to Nginx type of dummy type of code, which is running in that. So these are the applications which are running. In case I scale my application to a level that my cluster is unable to accommodate that, you would get some set of errors. I'll try to scale it now, but it could be a possibility that it doesn't reflect the data instantaneously over there. So what I'll do, I would show you the failure scenario in my other cluster. I've made the failure to happen, and I have already configured that, so I can show you in that cluster as well. So I've scaled the number of replicas to be 50. Let's see whether my cluster is able to accommodate that. Few are in container creating state. These guys have gone to pending state. So there is an issue. There is a lack of resource in the cluster. My containers or the pod which are coming up, they can't be accommodated because I don't have that much of resource. Then it will go to pending state. Let me scale a bit more, say 200. Then for sure it would be going to pending state. Okay, so let's wait for a while and see if our data, which is there, that would be showing up. I have other matrices as well. You can find the metrics section here. And here you can select what type of matrices you want to see. You want to see container matrices, what type of matrices, CPU exceeding percentage, memory related information. You want to see data with respect to persistent volumes, which are there in the cluster, or on the node level, you want to have an insight. It would show you all the data. So if I'll go and see the CPU usage in millicores, you would see that suddenly it has started to increase. And at one point in time, it was too high. It was at 7:52 a.m. when I was like trying to keep everything ready for this demo. You can see that it has hit too high. So this particular setup looks so beautiful and it is integrated so quick. I just need to select a radio button and provide a log analytics workspace. And the all set of data starts to get captured. But in case I want to do Prometheus scraping and I want Prometheus way of monitoring my solution, then it becomes more troublesome activity, right? Normally what we do, if I have a Prometheus monitoring solution to be deployed in my cluster, I would be actually going to, let me skip a few things in my slide and show you the Prometheus one. So I would need to have Helm charts placed. I would need to have some operators created, some custom resource definitions created. And at the end, with the help of Prometheus and Grafana, I would be able to visualize the complete data or the monitoring data from my cluster. So I have done that as well. Just let me quickly take you to the Grafana dashboard. Here, there is another cluster running whose data is showing up in this Grafana dashboard, the second cluster which was running. So this is the cluster which is not in that good state at this point in time. Already things are in pending state. So our resources have hit a limit in that case. So if I go to monitor task, I can show you there as well. You can see the data in monitor here. And you would find that I would say visualize. Let me go to the container section. And here, we can click on this view monitored cluster. Can you see this? Critical is there, total is there, warning is there, unknown is there. One guy is showing critical, and that critical cluster is this. In a while, you would start seeing this as also critical. I am having these many 223 pods, out of which 206 pods are in trouble. Here on the Azure Monitor dashboard itself, it clearly states that one cluster is having a critical status, one cluster is having a warning status, number of nodes which are there in the cluster, number of user pods which are hosted on that cluster, and number of the system pods. If I don't take an action, in a while, this warning will also convert into critical status. So here you can visualize from here itself. That gives us a good visibility. If I click on this and get inside the cluster, I can see that in the monitoring section, how we saw. So this is for the other cluster. How do you configure this Prometheus? When I have to run Prometheus, it's like an open source metric solution which is there, right? It is part of Cloud Native Computing Foundation. I need to deploy my Prometheus servers in that, and it's not an easy task. Let me show you my resource name. I'll set my apply to get into the other cluster. AKS-cluster1 is the name of my cluster. I think the name is resource group is that. Let me check quickly. AKS cluster 2, and I'm looking for 1. That's so foolish of me. Okay. So yes, now if I do kubectl get nodes, I'm talking to my other node, other cluster. It would just have 1 node in the cluster. So I've switched my cluster context for my kubectl. And if I do kubectl get pods -n kube-system, you will get terrified now. Why? Because you would have a lot of resources running like this. This is the general one, but if you see here, if I just do get pods, I have the Prometheus ones also running. Can you see this? This Prometheus ones are the one which will help me to run the Grafana dashboard and the Prometheus alert manager and all that. So I am maintaining 1, 2, 3, 4, 5, and 6 pods to actually serve the Prometheus monitoring. But if I say you that if you have Azure Monitor, you have to do nothing to do that, how cool that would be, right? I don't have to host a separate Prometheus server to get the Prometheus monitoring done. With Azure Monitor, it's pretty easy. Let me quickly go to there is a configuration map file which I apply to my agent which is running. This is a configuration map file for Prometheus data collection settings. And in this, you just need to say that I need to monitor my pods. I've set that flag to true and few other stuffs. From which URLs you want to collect the matrices and from which namespaces you want to collect the Prometheus matrices. It will start to do Prometheus scraping, grab the data and show that to you. So this configuration, when you do, you can even add some annotations to your pod definition and you can have them configured for it. If I have, okay, so let me switch my cluster context. I'll show you I've configured that. So in this cluster, in cluster 2, I have manually configured Prometheus and have a Grafana dashboard, which is serving from here. But in case of the other cluster, the AKS demo, I'm entirely using Azure Monitors functionalities and I've enabled Prometheus scraping and I'm able to collect Prometheus data from there. So if you go to matrices, I'll go to the logs. In the log section, I can run a query and show you that I'm collecting matrices from this. Let me run this query once more. You would find that a lot of data would get configured. This Prometheus is grabbing all these information from my cluster. And it did that only because I have enabled that particular Prometheus scraping in my cluster. So if I do kubectl get pods, and I have my Nginx, so kubectl, yep, these pods which are running in this cluster, they are being enabled from Prometheus scraping. And how did I do that? I had specified in my file that I want to do Prometheus scraping for my entire resources or type of applications which are running in my default namespace. And that is how this data is captured. So Prometheus can be enabled with Azure Monitor. It can be integrated so well with Azure Monitor that you would not realize the pain of it. Let me take you to my slide. Here in this diagram, it makes it pretty clear. I have the node. I can have a node exporter, and from there, I can push in the data to my log analytics agent. This agent is running in every node in the cluster, and that grabs the data and pushes that to your Azure Monitor. Here, pod level information can be collected. You can add this annotation that you want to have the scraping. You collect your matrices, the port number, and the type. All those things can be added to each of the pods. So when you are defining your YAML file, in that itself, if you add the annotation, that would be like how many ever replicas you're creating, it would get added to all of them. Now, service level monitoring also can be done. The endpoints which the Kubernetes service which we create, you can add them like this in the same config map file and apply those changes. Your OM agent, which is running in every node in the cluster, that will help us to grab that information. So I'm almost done. I just want to show you that OM agent, which is actually helping us do this. Here, if I do kube-system, you should see this. This OMS agent, this is what I was talking about. These are the guys which are actually configured now to do the Prometheus scraping. I have applied that config map so that it can pick up the data from each of the pods which are residing in default namespace. If I have any other namespace, my Prometheus scraping will not be done for them. I need to manually go and change the configuration map and apply the changes again. So instead of deploying Prometheus server, Grafana dashboard separately or having different logging and monitoring solution, we can look for a central solution like Azure Monitor and have Prometheus scraping enabled for it. That gives us a better perspective or better solution for managing our entire cluster. And in this view, you can see that on Monitor web page, you have both the clusters visible. It's just not one cluster. If my cluster is running in AKS, my cluster is running in Azure Stack, my cluster is using AKS engine to deploy, or my cluster is running in on-prem, Azure Monitor can support any type of deployment of Kubernetes. And that's one of the beautiful services provided by Microsoft, which can be like widely used to monitor our entire cluster, whichever environment it is in. So here you can switch the environment and you can have a view. Azure Stack and non-Azures are in preview stage now, but very soon they would be also in full-fledged features would be enabled in that. So that was all from my side. Let me quickly switch. I think I'm bang on time. Yes.
All right. So
yeah, any questions for me? If we have,
yes,
I see them. I'll parallelly reply them at the back end. But if you have any questions which I can pick, I would love to.
For you to take your questions. Okay. Yes. Here is the first question.
Yes, all of them do the same thing. One, they are like integrated together, time seriesing plus showing in the dashboard format. So collecting is one activity, converting it to the time series data is another activity, and then showcasing that on the dashboard is the third activity. Prometheus has a collector but plus a time seriesing one, plus it adds on Grafana, which is another tool altogether, but we use Prometheus and Grafana together because Prometheus doesn't have its own dashboard. Same way, Azure monitoring is like consolidated view of everything. It does all the three for us. It provides a dashboard, it does scraping, it collects everything it does.
All right. So there is another question from Arun.
It depends on the size of the node, Arun. Maximum node, 250 nodes in a cluster, maximum pods, 110 pods in a cluster, particular node. Entirely depends on the size of the node as well, like number of resources, how much resource I have in particular node, that many containers can be spin up. Suppose I'm spinning up, I'm foolish, I'm spinning up a very big container and that is eating up all the resources which are there in that particular node. I would be able to run just one of them, right? So it entirely depends on the configuration we are picking up for our nodes.
Okay. There is one question from Vijay Kumar.
How to monitor specific pods related to my application. So the Azure Monitor, when I said collect data from default namespace. In default namespace, my application pods were only running. And whether let it be my guestbook application pod or my Nginx deployment view, controller view, pod view, all views can be seen on the Azure monitor. So it gives you pod level matrices for your application itself. It's just not giving for system pods, it gives for your application pods as well. So the pods which I was referring in the example was application pods.
So I will just take one last question.
Sure.
Okay, so yeah.
Does AKS has an option to manage worker nodes so that customer only has to care about applications? Azure Container Instance is one of the options, ACI it is called as, in which you can, in case you're using web application and you want to host in containers, web app is also one of the solutions, but ACI is the solutions for this, for which you're looking. I think you're trying to compare with AWS Fargate, EKS Fargate, then ACI is the option in case of Azure.
Awesome. So Mamta, looks like there are so many questions.
Yeah, true. I'll reply them on the back end, no worries.
Sure. That would be great.
Yeah.
So thank you, Mamta, for joining us today.
Thank you. Thanks a lot. My pleasure. Thanks for having me. Yeah, bye.
Thank you so much. Okay, bye. So that was Mamtaja from Tech Scalable. And next we have Jay Sharma. And let me tell about him. Like till now, we have seen speakers who are like industry experts and who have like so many experience, so many years of experience. But Jay, let me tell, like he's a student, and it's really glad to have a student and have such great knowledge about his domain, and he's very active in communities as well and giving talks here and there. So we are really glad to have him. So let me bring him on board. Jay Sharma.
Thank you so
Hello,
much
Jay.
for having me. Thanks for a nice introduction as well.
How are you doing, Jayesh?
Yeah, I'm doing great. Looking forward to the presentation and talking about Kubeflow and machine learning with the different people. I guess a lot of enthusiasm and participation from the people here. So it'll be fun, I guess.
Yes. There are like more than 400 people live right now. And like we are really like pumped up for your session. And yeah, so you can give a introduction about yourself, like what you're doing and what your session is going to be about today. Meanwhile, I'll screen on the
Sure.
slide.
So I'm Jayesh. I'm in my current third year at IIT Bhubaneswar, and I'm actually pursuing a major in electronics and communication, but I have a lot of interest in cloud computing and other technologies. So I've also taken up an ambassador position with Microsoft, Microsoft Learn Student Ambassadors. So what we do is we look at Microsoft technologies, we practice different modules on Microsoft Learn, and when we are comfortable with technologies, we host sessions or attend conferences where we talk about all the technologies. So what I do is I usually try out new technologies like Dapper or maybe Kubeflow, and then I prepare presentations and I run demos to help other people learn as well from them. So my entire motive is to help you explore new avenues so that you can go ahead and check those out on yourself and do some experiments and get back to me if you have any questions or not. I also write some blogs and make YouTube videos on different systems that I built. And any project that I continue to work on, I make some short videos on how I'm approaching it, what the problem is, and how I go about solving all of those. So do check out my channel as well. So that is a very short introduction about myself. Now I'll be talking today on Kubeflow. Now Kubeflow is you can call it a framework for different machine learning on Kubernetes. So we're looking at why Kubeflow is important and how you're going to use it in your cluster. So I'll just switch to my screen if that's not a problem. Let me check. Yeah. Is my screen visible?
Yes, Jayesh, it's live. Jayesh, your screen
I
is
hope
live.
you can see my screens now.
Yes.
Yeah, sure. So I'll go ahead. So we'll be talking about what Kubeflow is and where you can use this application in your any project that you build, and what different components are. And we also see a live demo, not a live demo, I've recorded it earlier because I ran out of all credits in Azure, but I do have a demo ready for all of you. I will be looking at the code and how we can build pipelines and stuff. So let's just go ahead. So machine learning, as we know, has different stages. So there's the stage which deals with the data. When you pre-process the data, you validate, you transform, you perform splitting and other different actions on your data. After that, when the data is ready, you perform training on it. You choose algorithms, you define parameters, and then you go ahead with the training of your model on the data. After that is done, you usually roll out and serve the model as an endpoint or to any of your APIs or any application that you build. And after it is already deployed, you have a task of monitoring and checking whether it's performing as you expect it to perform, right? So these are all the machine learning stages. So whenever you're building an application in ML, these are the steps you go through. So how do you take this entire problem and develop something which can help you go through it really fast in a composable manner? So that is where Kubeflow comes into the picture. So we all are very familiar with how Kubernetes allows you to scale your applications and make applications really portable. Now, the problem is taking machine learning and deploying it on Kubernetes. Now, thinking about it, only people who have very specialized knowledge in Kubernetes will be able to use Kubernetes in such a way that you can create your different experiments or runs or machine learning runs on your Kubernetes. So Kubeflow wants to change that. It wants to make it really easy for everybody to deploy it. So you don't have to know a lot of how pods work or how do you schedule different runs and other things. You just need to have access to very common Kubeflow components, and those will help you in deploying your machine learning models. So why should we use Kubeflow in the first place? So as you already know about portability and scalability, that you can basically take your model anywhere and run any orchestration platform. And also it's very scalable. Apart from that, Kubeflow is composable. What composability is, we'll also be talking about it in later slides, but I'll just give you a heads up. It already has a lot of pre-built components which you can use. You don't have to write everything from scratch. And moreover, you can take different elements and then combine them in any way that you like. So there is no fixed way of executing things. You have a lot of options at your table. And then you can choose from different frameworks and different ways of executing and which you can want to train your model. Yeah, so what's in the box? What does Kubeflow offer? So Kubeflow has all of these different components which I talked about. So Jupyter Hub is like a notebook server on Kubeflow. So you don't have to deploy a notebook server somewhere else. You have it inside Kubeflow itself. So Kubeflow has a Jupyter notebook inside it. It has a training controller. So controllers are, you're referring to the Kubernetes controllers. For example, if you have deployment and pods and all these things. So it has a custom controller as well for TensorFlow training and also for other different frameworks as well. For example, XGBoost and all the major frameworks that you can think of, PyTorch, all of them have different controllers custom built for Kubeflow. You also have a serving deployment. So it helps you to serve your model once it's done training and all the stuff. You have Argo for workflows. So if you're familiar with Argo, it's an open source project where you have, it's basically used for defining a workflow. And in Argo, all the steps of a workflow are containers itself. So every step will be a container executing on its own. So in this way, Argo is really flexible, and you can workflows built in Argo can be run on all clusters and across different nodes. This is why Argo is really scalable and helps it. So the Kubeflow pipelines are built on top of Argo, and there are a lot of other components which we'll just be going over them in a short while. So yeah, the earlier diagram which we saw about machine learning stages, the ones which have been highlighted here are those which Kubeflow can solve for you. So Kubeflow can allow you to train a model, build a model, validate it, and train it on scale as well. If you want to scale your model across a lot of nodes, for example, if you are building a really complicated model and you want multiple machines running it parallelly and communicating with each other, Kubeflow can handle that as well with its own controllers. And then it also handles serving as well. So once you're done training, you can make use of different components inside Kubeflow, which allow you to serve. So that is it. Now, this is the different ways in which Kubeflow is being used currently. This is from a Medium post done by the Kubeflow community. So as you can see, ML pipelines are the most used features. Then there are notebooks, model serving, and distributed training. So all of these top 4 things we'll be discussing in today's presentation as we go forward. So yeah, so as I talked, that Kubeflow is composable. So what I really meant about that is, for example, if you have to train your model, so you'll have a large number of options that you can choose from. So the first thing is you can perform distributed training with TF jobs. I'll be talking about TF jobs in the next slide. So TF jobs are the custom resource definitions. They are different controllers built by Kubeflow. And using this, you can train some TensorFlow jobs, right? So you can perform distributed training using TF jobs where you can define, say, for example, you want these many nodes and these many workers, and you can submit jobs to this particular resource. Apart from that, if you want, you can run pipelines. For example, you have different steps. For example, if you have to define a model in first place, in the second step to register the model, third step deploying the model. So if you have a pipeline in mind, you can also use Kubeflow pipelines to design your workflow. And you can use regular containers. Regular containers are those containers which have the built-in controllers by Kubernetes. For example, pods. So regular pods you can use as steps inside your pipeline, or you can also insert the TF job controllers inside the steps of your pipeline. So the pipeline does not need to have just regular containers as an Argo. You can also use TF jobs inside of a pipeline. So there are multiple ways in which different services are intertwined with each other, and you can explore depending on how your use case is. Similarly, with serving, you also have multiple choices. So either you can use KF serving. Now, KF serving, it's like a high-level abstraction interface for all the different common frameworks, for example, TensorFlow, XGBoost, PyTorch. So it combines all of these together with KF serving. Or if you don't want to use Kubeflow service, you can also use Azure Machine Learning Service or any other framework that you're going to use. In this demo, you're going to use the Azure ML service. So we'll create a machine learning workspace on Azure portal, and then we're going to register our model with the Azure Machine Learning Service. So once it's registered there, you can perform operations like deploying it, looking for different metrics, or you can get an endpoint for scoring, for calculating the score of a machine learning model. So there are also multiple steps in which you can serve your model. So this is what is meant by Kubeflow being composable. So you have a lot of choice and options here. Now, this is a high-level architecture of Kubeflow, as we talked about. So you can see in the top, there are libraries. So Kubeflow control is used to deploy a Kubeflow into your cluster. Kube control is already familiar with that. Fairing, we're not going to talk about it in this presentation, but it's also one of the components, and you can check it out in your Kubeflow docs. In the systems part, you can see there are a lot of different services available. The first is Kataib. It is used for hyperparameter tuning. For example, if you have a model and you want to tune hyperparameters, so what Kataib does is it allows you to run it allows you to do multiple parallel jobs, and then you can tune your parameters differently in all of these jobs, and it selects the best one for you automatically. So that is what Kataib does on a whole. The pipelines are those which we're going to discuss, and we're going to see them in action. So pipelines allow you to use different steps in a composable manner, and then you can reuse all of these pipelines again and again. So you don't have to compose a pipeline again and again. You can just define one and run it anywhere, every time. Apart from that, there's also notebooks where you can put your code in there. You can run it there itself. So you don't need any other server for notebooks as well. Then there are low-level APIs which are single function APIs, which do most of the work. For example, TF job, which I talked about already. PyTorch job, as I mentioned, you can use any library you want. So you don't have to go with TensorFlow. You can choose PyTorch, or you can use XGBoost, any other different resources you want. So all of those have some resource defined inside of Kubeflow, which you can use. So this is, I hope this is clear about the entire architecture of Kubeflow, what it does. Now we'll get to TF job. Like, what is TF job? So you can think of TF job as being similar to a pod, but in that case, pods and deployments, those are inbuilt controllers by Kubernetes. TF job is a custom resource defined by Kubeflow for Kubernetes, where you have these particular options more available. For example, you can define a chief. So you can define what the chief will be. The chief is used for orchestrating the different training and performing tasks like selecting checkpoints for a model, something like that. You can also have a parameter server. The parameter server will be responsible for coordinating the events between different worker nodes. For example, if you want to share some information between different worker pods, you can use the parameter server for defining, for example, the common information. The worker pods will be those which perform the training of the actual training of the model. And the evaluator can be used to evaluate or compute your score for any model that you build. So TF job is the entire definition. We'll look at the YAML file here. So this is how it looks. In terms of comparing it with pods, in pods would have defined containers right away. But in this case, you can have different, different parameters where you can specify either if you want a parameter server or you want a worker pod specification. You can also add the chief and other things we discussed in this case as well. And so we look at the worker part. So the worker will have 3 replicas. I defined it to have 3 replicas. And then you can specify this what containers it will be running. It will be running a TensorFlow container with a particular image. Like this is the name of the image which you can use, and the command which you want to run on it. So I'm running Python trainer task, something like that. So just a very what do you call it? An idea of how a TF job YAML looks like. This is a parameter server, worker specification, the image with your code, and the commands in which you can begin your training process. This is how a TF job YAML looks like. Then comes the Kubeflow pipelines. So pipelines is the entire offering by Kubeflow. It has a UI which we'll be looking at. So entire user interface for managing your pipelines, checking what steps are running currently and what are the different parameters corresponding to each step. Apart from that, it also has an engine for scheduling different workflows. And then there's an SDK. This is an SDK in Python when you can actually define your pipeline, like what all the different steps will be, what will be the inputs, what will be the outputs, and how long it runs, what are different replicas, and all these things. We're looking at the code right now. And apart from that, it also has connections to the notebook. So this is what a pipeline definitely looks like. So it has input parameters, it has output parameters, and it is also has a Python. Most of these things are already covered. So I'll just go really fast so then we can get to the demo part of it. Now this is the entire idea. So first we have a Python file with the code. For example, if you have a training code here or maybe other pre-processing code. So you have some Python file here. You create an image out of it. You build a container on top of the file. And then you use the Python, the DSL library, which is provided by Kubeflow. It is used for building the pipelines. So you can provide annotations like kfp.dsl.component to define a particular component, or container operation define a container step. So you define a container step using the container image that you built. And then you can incorporate all of these different container ops, like container ops will be a particular step. So you can combine multiple container operations into a single pipeline using the kfp.dsl pipeline. We're looking at the code to understand much better. So this is how you build a pipeline, and then you can run the pipeline inside the pipeline server. So I'll just go over to my code file to show you what exactly is meant by all of that. So if you look at the code here, you can see there's 4 different parts: training, pre-processing, training, register, and deploy. So in pre-processing, all of these are just regular Python files which we have here. So in pre-processing, we'll be looking at different data operations that you have inside pre-processing, like processing image, walking images, all this stuff. And then you have a Docker file which builds an image specific to the pre-processing software. For example, if you have inside pre-processing, we'll be copying the particular data file inside the container and we'll be running the file. That is the idea behind the pre-processing part. Then you have the training part where you can go. If you look at the training file, you have the application of Keras here. So you can define a model here, you can select parameters, different parameters, and you can actually train your model inside this. So it's just a Python file. You can either write it on your local editor, or you can choose a Jupyter notebook inside Kubeflow to do any of these tasks. So the idea is to split your entire machine learning application into different parts. So training, register, deploy, will creating different images for each of them. And we're going to push all these images to the Azure container registry so that Kubeflow can then pull those images when it's running its pipeline. So when a pipeline is run, it takes images from the container registry corresponding to every step. So for example, if I'm in the pre-processing step, I'll be pulling the pre-processing image, the image that I built here, and I'll be running this particular script inside of it. So that will be how the first step will be run. And then the output will be stored at a common bucket or some other place, and the next step will be run. That is the training part. So the training step will pull its own Docker image, which is built on this particular Docker file. And this will be running the train.py file that you created inside of training. And similarly, you have register and deploy. So register and deploy have the task of registering your model with Azure Machine Learning Service. For example, if you have a machine learning workspace created on Azure portal, you can register the model that you have built to the workspace so that you can look at logs, you can monitor how the different parameters of your model are. And then you can also deploy using the machine learning workspace. So deploying will allow you to create endpoints for scoring, right? So this is how you register different part, and this is deploying part. So I'll just go over. So first we'll have to create a cluster on Azure, install Kubeflow on there, and then we have to set up a port forwarding, because Kubeflow has its own dashboard which you can view, but it's on the cluster. So if you have to access it from your local machine, you have to set up a port forwarding from your own machine. So those steps I can't do it right now because my Azure Credits are off, but I've recorded all of that, so I'll be showing you that now. So we'll be looking at the Kubeflow dashboard and see the different steps which you can perform there. Let's go to the again to the this is about yeah. Just give me a second. Yeah, so this is the Kubeflow dashboard that you see when you start a port forwarding. So this is a welcome screen. Then you have to start your setup, and basically it is available at 8080 port of your local host when you set up the port forwarding. So you can go ahead and define a namespace for your Kubeflow applications. So I'll just use the AKD demo as you're doing it here. Now this is how the dashboard looks like when you open it. So there's the pipeline option, notebook server, Cative, all the different parts here. So if I want to create a notebook server, I'll just go over to the notebook servers tab, and then I'll create a new server here. It's pretty simple. The entire UI makes it really possible for you to deploy it really quickly. So I'll be deploying my notebook, which will be called AKD notebook right now. You can set a custom image if you want, if you have an own image with your own dependencies installed in your Python. So you can use a custom image, or you can use any of the traditional images. You can select GPUs if you want your training to be done on GPU, and their data volumes to be attached. We won't be using persistent storage because it will require creating other resources as well. So just for the purpose, we can click on launch and it will start up the notebook server. It usually takes a lot of time to spin up servers and also consumes a lot of resources. So we'll look at pipelines meanwhile. So when you click on the pipelines tab, you'll see, it'll load a bit, it just takes a time. There are some of the tutorial pipelines already built for you, and you can also create a new pipeline by clicking on the upload button. So when you click on the upload button, you'll see you have to specify a pipeline name, and you also have to upload a pipeline file, right? So what is this file that you're talking about? So we'll be looking at, just give me a second, I'll just show you what the pipeline file is. So this is the pipeline file which you have. Now take a look at how I defined the pipeline file. I've used annotations from DSL. So this is how you specify that this particular function is the pipeline, DSL pipeline. Inside the pipeline, I have the different steps. Different steps have been defined as container operations. So this particular thing is a particular operation. So this is a pre-processing step. This is the first step which happens. We define it using container op. Then these are the parameters that you can specify on your own. Like it doesn't have to be according to a particular script. So you have to name the container operation. You have to use the image for this particular container. What command are you going to run inside this container, and the arguments for the container, right? And then there's a second step for training. Then similarly, we have different steps. So this is how you define an entire pipeline here using container ops and their annotation. So this is, and when you're done writing a pipeline code, you can then compile it using Python command, and then you'll have something like this, a zip file here. So I'll be using this zip file for uploading it to my Kubeflow. So let me just go over to yeah, this is the place where I'm selecting. Let's give me a second. Sorry. Yep. Yeah, so this is just filling all the different metadata, and then we can go ahead and upload the file which I showed you, the zip file. So there it is. And once you are done uploading it, you can then click on create. So this will create your pipeline. Once your pipeline is done creating, you can see a graph for the different steps. Like the first is the pre-processing, second is training. So what Kubeflow does is it takes that Python code that we had on pipeline and convert it into different steps using Argo. So they have already have, if you click on any of the step, you can see the argument that you defined there. Like whatever command that we're going to run, the image it's going to run on. I don't have any image right now because it'll take a lot of space. So I'm just keeping regular placeholder values there. Now you can go ahead and create an experiment for the pipeline that you have. So you can create an experiment and specify the name of the experiment, description, and stuff like that. So once an experiment is done, you can start a run. Like you can create a particular run of a pipeline. So this is how you can make sure you can run this pipeline again and again. So already you have a pipeline defined. You can run anytime you want across any nodes that you wish to run it. So I'll just click on the pipeline that I want to run, which is the pipeline which I just created now. And then we can look at, these are the parameters that I want to focus at. Like, what are these parameters? Like tenant ID, we have, where are these things defined? So you can go back to the code inside my Visual Studio, and you can see that the pipeline that we defined, we use these particular parameters inside the function definition. So these are the parameters which you're going to use across what you call an entire application. For example, if I am running a particular, say, registering my model or deploying a model, these are the parameters which I'm going to use. So I'll be taking those parameters before I start to run. So whatever the parameters that you define up there will be available at the start of your pipeline. So if you look at the register file here, so register will also be using tenant ID, subscription ID, all of these things for registering a model with the Azure workspace. So this is where you use all of these parameters. So you have to first make sure you list out all the parameters that will be helpful inside the application, and then make sure that the people who are running the pipeline will be providing all of these parameters when they start a new pipeline, right? And similarly, you can also look at deploy script. Deploy script also uses all of these parameters for deploying your model to Azure Machine Learning using this command, Azure ML model deploy. So this is how you make sure that all the parameters are there in place and there is like no null values in this case. So we'll go back now to the, yep, just give a second. Yeah, so I'll be just filling the different parts. I think I'm running out of time, I guess. Yep. So I'll just go over quickly about different filings. So I'm just going over to my Azure workspace and looking at the application ID, tenant ID. I'm just taking these values from there and putting it in my workflow. Yeah. Yeah. I'll be showing you the machine learning workspace here now. That'll be important. So you have to have a machine learning workspace when you want to deploy your app through machine learning, Azure Machine Learning. So I'll just go over to a resource that I created, which is called CubeSpace. Now, this is the place where you can register your model. You can, I'll be launching the studio to allow you to see it better. The studio has a lot of places. It has its own offerings of notebooks. It has its own pipelines and stuff. And if you look at the left side, you can see the models. So this is where your models will be once you deploy it on Azure Machine Learning. And the endpoints, now this is the point where after you deploy the models, all the different endpoints will be available here. For example, if you want to test your application, test your model right away, you can click on the endpoints tab and choose whatever model that you have. So I'll just add the CubeSpace name of the workspace here, and I click on start. So this will start my pipeline run. If I click on the first run, I'll look at the different steps that are in process right now. So just give it a second and it'll show you. And this is the first step which is currently running. And you click on it, you can have information about all the different, like the pod information, like what pod is going to run this particular step. When I click on it, you'll have the improper parameters. You can also have the visualizations if you have some other plugin that you have. So you can put it in here and look at how your pipeline is actually running in real time. And moreover, if you click on the pod, you will see what pod exactly is running your this particular step. So if you want to debug it, you can later on take this name of the pod and check the logs of this particular pod and see if everything is going as you wish it to. This is the entire demo for Kubeflow, and I hope you understand how pipelines and stuff works. That is the end of my presentation for now. Yep. Are there questions?
Yes, Jayesh, let me just find out if there are any questions. I'll show on the screen.
Sure.
Yes, there is one question from Shivam.
If I have to retrain my cluster machine learning model or add in parameter, can I do it in clusters? No, if you want to make any changes to your machine learning model, you can do it in your local editor like I showed you, or you can spin up the notebook server, make changes there, and create a new image. So what happens here is that any pipeline that you run, all the steps are basically container images. So whenever you're trying to make some changes to your code, you have to build a new image and push it to your registry. So when the new pipeline runs, it will pull the newer image and your whatever changes you have done will be shown in effect. So that is the entire idea behind making any changes.
Okay, awesome. So I will take one more question that is also from Shivam.
If one of my cluster pod die while training the machine learning model, in that case, my model is not trained. how to cope up with the situation. Like if you have a single pod which is running, for example, either you can have multiple pods training your model. For example, if you're doing distributed training like with TS jobs, you will have multiple different pods running your training your machine learning model. So if one of them fails, it won't be a problem because it will be backed by the parameter server. So the parameter server will be holding all the information for a particular pod. But if you have only a single pod which is running your machine, which is running your training, and in case if it fails, then it will have different checkpoints. For example, the master that we define inside TF job will be checkpointing different parts of your model. So you can at least get back the parameters from that particular checkpoint if you face some other future point.
All right. So yeah, Jayesh, I'll share the live YouTube link. So because there are a few more questions in the comment box. So since because of the like deadline,
Yeah.
so you can go offline and answer to those questions.
Yeah, sure.
And we will be also requiring your slide so that we can share it with our participants post the event.
Yeah, sure. I already shared this slide with the section.
Awesome, awesome. Thanks a lot, Jayesh, for joining us today, and we look forward
Thank
to
you for
have you
having me.
as well.
Yes, my pleasure. Thank you so much.
Thank you, Jayesh. All right, so that was Jayesh Sharma, and with this, we have come to the end of today's conference, and a lot of people would be like waiting for quiz 3. So yes, it's here, but before that, I would like to show you a few things before you start with quiz 3. Okay, just let me. Just a second. Okay, yeah, it's here. So if you guys are able to see my screen, so yes. So before we start with our quiz 3, here are few learning resources that you can check out. And if you are looking for an opportunity to get started with Kubernetes, like if you don't have any prior experience, so this particular learning link will help you a lot. Next, as I was mentioning earlier today morning, we have started with Azure Developer Community. So it's a pan-India community which is spread across multiple cities in India. So just to mention, like there are 100 plus communities right now in India. So you can go to this link and you can check out the upcoming events. So to attend any of these events, you need to join your nearby communities. So on the website itself, you can search for your nearby communities with that particular region, city or state name. For example, Mumbai, Delhi, Hyderabad. And you can join that group so that you will be getting regular notifications and the live URL for joining the event. So tomorrow we have a similar event. So we are starting with our first event for Azure Developer Community, which is Azure Fundamentals by Vivek Sridhar from Microsoft. So you can go and join these communities and attend tomorrow's event. Also, in tomorrow's event, we have quiz where you can earn Azure credits worth $100, and also there is a chance to win Microsoft certification exam voucher. So it's really awesome. So there is two things, like you can learn and upskill, and also you can earn these amazing rewards. So go and join these communities to attend tomorrow's event. Next, we have Azure Dev Challenge. So as the name suggests, it's a developer challenge, and this event is open for professionals, but also to encourage student developers. We have kept some like winning positions for student developers as well. So you can visit challenge.confirm.com. This is the link where you can find all the details about this challenge. So just to give you a quick gist about what you need to do. So to participate in this challenge, you first need to register for this challenge. Once you register, you'll be getting 3 different links, starting from Python on Azure, Node.js on Azure, and .NET on Azure. So you can choose any of these categories and complete the learn modules. So there will be several learn modules that you need to complete. Once you do that, you will be eligible to get Azure credits. If you come to the top positions, like for professionals, it's top 400 people will be getting, and for students, developers, the top 150 people will be eligible to get Azure credits. Apart from this, we also have like cool swag packs for our winners. So go check out this website, and the submission ends on 31st of March. Next, we have Azure Developer Stories. So this is the second version of Azure Developer Stories. This is version 1. So this time we are inviting developers who can come and share their experiences about their technical knowledge in a form of writing a blog, creating video content, or any other contents. So you can share experiences that would be actually benefiting uh, the rest of the community, and there are amazing rewards for you. So the top 5 winners will be getting Microsoft Surface Pro X, and along with that, we also have Azure credits, we have like vouchers, we have cool swags and t-shirts and many more. So go check out this website and start submitting your blog for Azure Developer Stories. So today's conference would not have been like a really great success if we did not have these streaming partners. So we are really thankful to our streaming partners. So this whole conference was streamed to these 4 channels: Cloudrix, Computer Science Carriers, ShareLearn, and Tech Primers. Then we had 30 communities that helped us spread a word about the event. So starting from Bangalore CNCF meetup, Bangalore Jug, Cloud and DevOps group, Containers meetup, CyberSci Quins, developer, student community, Docker Bangalore, Docker Delhi, Docker Pune, .NET Bangalore, dot question mark, Elasticsearch Explorers, Elastic Users Group, Geek Community, Hyper, Trace Community, Jug Hyderabad, JavaScript Meetup, Kubernetes and Cloud Native Online Meetup, Kubernetes and Cloud Native Computing Pune, Kubernetes Sri Lanka, Mozilla India, Mumbai Jug, Nashik Data Science and Cloud Community, Open Community, Pilot is Bangalore, Redis Labs, Serverless, Soda Foundation India, and Technology Cafe Bangalore. So we are really thankful to all our streaming partners and community partners to make this event a really success. Also, this whole event was sponsored by Microsoft Azure. So we are really thankful to them to sponsor this event and sharing the learning resources that we are sharing with all of you, so that you can get benefited on multiple technologies, and also specifically on Kubernetes on Azure. So guys, we would love to hear from you, like how did you find the whole conference? So you can make a tweet using hashtag Azure Kubernetes Day and tagging us with KonfHub on social media. So we would be waiting for your tweets, and we will retweet them as well. So yeah, that's all, and we'll be starting with quiz 3 now. All right. So actually, we have been late for the quiz. So we'll be starting it now. So here is the link. You can go and start participating. The link is quiz.confirm.com/quiz3. All right, so let's see like who are the winners, like who are the top scorers as of now. Let me show you. All right, so yes. All right, so guys, you can find the link below the screen and also in the comment box. So meanwhile, I would bring Ganesh from KonfHub, who will be like sharing the answers for quiz 1 and quiz 2 that you have participated in morning and afternoon quiz. Hi Ganesh.
Rohit. Hi Rohit.
Hi. So Ganesh, you can share your screen so that we'll put that on stream and you can share the answers.
Yes. So can you share my screen?
Yes. Yes.
All right. So let me go back to the answers. So hi everyone over there. I hope you are having or you had good time in the conference today. So let me quickly take you through the answers for the quiz 1 and 2 while many of you are attempting quiz 3. So though we have fun attempting quiz, the ultimate objective is learning and knowledge sharing. So all the questions are from Microsoft Learn learning modules. So the links are available here and you are welcome to go through it. So this is the morning quiz, the first quiz before the conference started. And for quiz 1, right? So first question was, which of the following is an invalid reason for choosing Kubernetes? The answer is less complexity. Which is the correct Docker command to rebuild a container image? The answer is C, Docker build. Third one is, which of the following sentences describe a container image the best? So it's a read-only portable package that contains both software and the operating system. Fourth one, when submitting data to cognitive services in Azure in a container, where is the data processed? It's in the container. Fifth one, relating to running Docker with Azure container instances, which restart policy is typically best choice for long-running tasks? So because it's long-running task, it's always. So by default, the values of an environment variable can be seen in the Azure portal and the CLI output. The answer is true. The word Kubernetes stems from the Greek word meaning helpsman or pilot. So unit of scheduling Kubernetes is, the easiest one perhaps the question is this, pods. And maybe this even more easier, the short form of Kubernetes is of course K8s. And how many sides or spokes does the Kubernetes logo have? The answer is 7. So yeah, in keeping with the bog theme, it was named Project 7. And with that, the logo has 7 sides. So these were the first questions in the first 10 questions in the morning quiz. So in the afternoon, 1:40 to 1:50, right? We had the quiz number 2, and these were the questions and the corresponding answers. So the first question is, why are Kubernetes secrets safer than plain text values? Because they don't let sensitive information open to all users and hide them in the workload. Which troubleshooting command can be used to view container startup events? AZ container attach. Suppose you work for an event management company. Your events websites needs persistent storage. Which feature of EKS will you use? The answer is storage volume support. Suppose a software solution makes use of a website as one of its critical component. The website is the only component that depends on a caching service. Which strategy would fit the deployment of these two applications best using Helm? So you can create a single Helm chart for both applications and set the caching service as a dependency chart. The fifth question, what component is used to implement Azure Monitor for Containers, OMS agent? What Azure resources do you have to provision first before you implement Azure Monitor for Containers? The answer is Log Analytics Workspace. Last three questions. What type of agent does GitOps rely on when used on Azure Arc enabled Kubernetes clusters? Answer is Flux. Which tool can be used to automate configuration of GitOps for Azure Arc enabled Kubernetes clusters? Azure Policy. Azure Arc namespace hosts the Azure Arc enabled Kubernetes agents. And the last one, which of the following is not an advantage of Azure Arc enabled Kubernetes? It's managing cluster creation. So Azure Arc enabled Kubernetes itself does not provide the ability to manage the cluster creation. Yeah, so that's about the first two quizzes. So if we have time, we can discuss the answers for quiz 3 once the quiz time is over. Yeah, that's all from my end. Handing over back to Rohit.
Thank you, Ganesh. So yeah, so once we are done with quiz 3, maybe Ganesh can show the answers for that as well. All right, so let's see who are there on the top leaderboard. All right, so guys, we are about to close the quiz. Okay, so here are the top 3 winners we have for quiz 3. All right, guys. So thank you so much for participating in all the 3 quizzes, and the winners will be contacted via their registered email address, mostly by Monday or Tuesday. And before we wrap up the whole conference, I would like to ask you to submit your feedback. So here is the link to feedback form. It's con.me/akd-feedback. Go and submit your feedback, and those who are looking for certificates, participation certificates, they can opt for it there. Also, guys, do follow us on Twitter and subscribe to our YouTube channel. The links are here so that you get regular notifications on upcoming events. And before that, I would like to show you about Azure Developer Community that I was mentioning earlier. So tomorrow we have our very first meetup under Azure Developer Community. So people, those are looking how to register for that event and get the live URL. So you need to go to this link. The website link will be available in comment box and also below the screen. So here is the event. What you need to do is you need to go to this and select your nearby communities. So when I say nearby communities, you need to give the name of region or city or state from where you want to attend. Like suppose if you are staying in Bangalore, or maybe if you're staying in Chennai, then you can search for it and you go to that particular uh, meetup page and register there. So once you RSVP for the event through these communities, you will be getting the live URL for tomorrow's event. And similar to that, we'll be conducting 1 or 2 events every month. So for February also we have another event planned, and likewise we'll have events every month. Also, apart from that, since I was mentioning about Azure Developer Stories, so let me show you what is it. So this is Azure Developer Stories version 2. First thing first, you need to understand what is it. So we are actually encouraging developers or people, those who are looking to upskill and also share their knowledge with the community. So to learn, what you can do is register for our upcoming events. So here are the events already listed, and these were some events which already happened this month. So you can register for the events so that you can attend these sessions and get to know about these several topics. Once you learn about these topics, you can share your experiences in a form of a blog or uh, a video content. After you do that, you need to submit that, and if you are one among the top winners, then you'll be getting Azure exam pass. So here it is, and yes, you can also get a chance to win Microsoft Surface Pro X. So the top 5 winners will be getting it, and the next 25 valid blog submissions will be getting a swag pack, and also others will be getting cool t-shirts. So yeah, there are a lot of things for you to win. Similarly, we also have another challenge that I've shown you earlier. It's developer challenge. So here is the website. In case if you are looking to how to participate in this, like here is the YouTube video for you, so you can watch this video and you'll be getting like how to participate in this challenge. And to give you a gist, to participate you need to register obviously, and after that you'll be getting several learning collections. Out of those you can complete any one of them, and then once you get upskilled you can like uh, submit your profile, and if you're one among the top winners, then you'll be getting Azure credits and other things. So here is a list of swags and rewards we have for our winners. So yes, that's all from my side, and with this I will bring Ganesh once again back so that he can show you the answers for quiz 3.
Hi, Rohit.
Yeah, you can show the answers for quiz 3 which just happened.
Yes, I will share my screen. And yes, are you able to see the quiz 3?
Yes, Ganesh.
Yep, I think the answers are visible now. Okay, guys, I hope you had a good time with the quiz 3 as well. This is the last quiz of the day. So let me take you quickly through the answers. Kubelet runs on each node and ensures containers are running in a pod. Scheduler manages the assigning nodes to pods depending on resource availability. So the simplest method to identify the operating system of an Azure Arc enabled server, it's use the Azure Arc enabled servers blade in the Azure portal. What is the primary Azure Monitor related benefit of Azure Arc enabled servers compared with servers which are not Azure Arc enabled? It is the ability to deploy and configure the log analytics agent via VM extensions. So single control plane and several node is an example of Kubernetes cluster architecture. So what are node pools? It's a configuration to create multiple node types in a same cluster. So what does the HTTP application routing add-on do? It allows for instant exposing of an app to external networks that you can create ingresses. What is a container registry? It's remote storage where we can store our images safely so Kubernetes can download and run them. What's a manifest file? It describes everything needed to create and manage a workload. The last question, what's the purpose of the cluster IP service type? It is to group pods into one single IP that's only available within the cluster. Yeah, so with that, I will stop my screen share and hand over the control back to Rohit.
Thank you so much, Ganesh, for sharing the answers. So yes, and with this, we have come to the end of the conference. So thank you all for joining us today and participating in the fun activities and also attending the sessions. So we organize similar kind of events like almost every month. So you can check out KonfHub.com website where you can find relevant technical conferences for every month. Also, on the same website, you can find links to all these challenges and the contests that I've just shown you. And yes, do join us for tomorrow's meetup. The link is there below. And yeah, looking forward to host you all again. Thank you all.